very good afternoon to our honored guests, faculty colleagues, members of the staff, students, and other members of our IIT J fraternity. We have gathered here this afternoon to celebrate the excellence of the research culture and traditions at IIT Jodhpur. And as we begin our program, I would like to welcome our guests for this evening, Dr. Jitendra Jadhav, Director of the Aeronautical Development Agency, and Professor Pushpak Bhattacharya, presently at IIT Bombay and former Director of IIT Patna. Sirs, it is our great pleasure to have you with us. And I would like to invite our Director, Professor Shantanu Chaudhary, to escort our guests to the stage. And may I also invite Professor Surajit Ghosh, Dean R&D, and Professor S.C. Bose, Head of IDRP, to please accompany the guests on stage. It is truly our honor to have guests of the caliber of Dr. Jitendra Yadav and Professor Pushpak Bhattacharya with us this evening, and therefore I'd like to request our director to felicitate our guests with a bouquet. Thank you very much, sir. Now I would like to invite Professor Surajit Ghosh, Dean R&D, to deliver the welcome address.
Thank you, Rachel. First of all, very good afternoon to all of you. I cordially welcome you all for this session, Scientific Excellence at IIT J, on the special occasion of the Institute Foundation Day. So we are celebrating 15 years. It's a great honor to welcome the chief guest of today's session, Dr. Jitendra Jadhav, Director, Aeronautical Development Agency, Bengaluru. I welcome Professor Pushpak Bhattacharya, former Director, IIT Patna, who will be delivering the Foundation Day oration. I also welcome the Vice Chancellor of Gati Shakti University. Eventually, he was a former colleague on deputation. So Professor Manoj Chaudhary, our Deputy Director. And I also welcome Professor Shantanu Chaudhary, Director, IIT Jodhpur, and other distinguished guests, my dear colleagues, staff members, and students who are there in this auditorium. Now, let me begin with that Indian Institute of Technology, Jodhpur is actively engaged in multidisciplinary research, where mainly our colleagues are focusing in cutting-edge fundamental as well as translational research, directly focusing on human health, technological advancement, and empowering young minds to become the intellectual resource of our country. That is our main focus. The Institute is running several research programs in diverse areas through its various departments and has published in highly reputed international journals, and their work also highlighted in various media platforms, both nationally and internationally. Our Office of R&D in the Institute is continuously providing specialized support, both administrative and also managerial, for the operation of all sponsored research projects, consultancy projects, and other R&D related activities. In addition to the Institute's support and also from various R&D projects, we are setting up many modern laboratories, and already we have set up state-of-the-art various laboratories, and also we are receiving continuous support from the various funding agencies to set up a few more new laboratories recently. Now, Institute has taken various key initiatives, and where R&D also played active role. Right? We have framed an IPR policy which is now effective for all the faculties and also students. We have provided immense flexibility to our faculty colleagues for running their project without any problem. We have also made digitization of research ecosystem, and we have implemented the e-office. The institute is recognizing faculty members and motivating faculty members by conferring institute awards for research excellence. Since 2020, 17 faculty members have been awarded with Young Research Award, Senior Research Award in the field of science, engineering, humanities, and management. Institute encourages faculty members by providing seed grant of 25 lakhs in some special occasions where needs are there. We have also provided more fund for setting up the state-of-the-art laboratory for new faculties. As of now, 107 seed grant projects with total outlay of 25.5 crore have been sanctioned. The seed grant projects granted on faculty members to support their research activities, to enable them in setting up their research labs when they just started in their journey in the institute. So in the year of 2021, with the visions of our director, Professor Shantanu Chaudhary, we have started, perhaps in the first time in the country, to support the young colleagues who do not have the exposure, foreign exposure, so they can set up the collaborations with the foreign universities in the name of International Research Mobility Grant to establish that research collaborations with foreign institutes. Now, all of you have noticed that after around 7-8 months, ACRB also launched similar scheme. Now, you can assume that the visions of our director to initiate this type of schemes for the sake of the young colleagues. This scheme basically also collaborate with these top QS ranking universities, where we support 10 lakhs. So far, 12 faculty members have been awarded with this scheme, which is around financial outlay of 1.2 crore. This all possible from the R&D overhead, and where all our faculty colleagues actually bought this money, because at the end overhead money only accumulated and we support this. Thanks to all my colleagues. Now we have created also excellent academic and scientific ecosystem, resulting in the submission of large number of research projects to various funding agencies. So this is a clear mark of the rapid growth of this institute. So apart from this, we have received excellent support from various funding agencies to build up the state-of-the-art research infrastructures and facilities. Now, all of you will be very happy that despite the COVID pandemic, so we might have forgot that just a year back what situation we gone, but despite of that, thanks to all our faculty that they fetch large number of research projects, where R&D also play a key role, support the faculty. And we are pleased to showcase that our significant growth as we received 757 sanctioned projects with total sanction grant of INR 408.5 crore from various funding agencies. Institute also encouraging faculty members to file patent for protecting their innovation and providing financial support to file their patents and also the maintenance. So towards this process, again, Office of R&D plays key role to provide its administrative support, starting from IP evaluation, IP filing, and its commercial exploitation. So recently, there is a significant increase in IP filing. So we have filed more than 50 IP. Now, the Office of R&D also contributed in setting up various chair professors, such as JJM chair professor, IPR chair professor, BIS chair professor, and today you have all heard from the Secretary of MIT that he has approved the MIT chair professor, where Office of R&D plays a role to formulate that chair professor. Now, the institute also constitutes the Center of Excellence in IP, which will be under the School of Management and Entrepreneurship, and a dedicated empowered unit of IPR cell will function under the COE of IP in SME. Now, it is our great pleasure to highlight the recent major projects and centers at the institute, like Jodhpur City Knowledge Innovation Cluster, a Section 8 company to carry out and sustain the activities of Jodhpur City Knowledge and Innovation Cluster, which is called JCKIC, and when it's a Section 8 company, it's called JCKIF. is one of the 6 clusters sanctioned by the Office of the Principal Secretary, Principal Scientific Advisor, PSA, Government of India, with a financial outlay of 9.5 crore. Next one, IIT I Have Drishti Foundation, which is the TIH Technology Innovation Hub at IIT Jodhpur, which is named called I Have Drishti, focuses on building cyber physical systems for computer vision, augmented reality and virtual reality. It's again a Section 8 company, not-for-profit organization promoted by IIT Jodhpur under National Mission on Interdisciplinary Cyber Physical Systems Scheme, Government of India. Recently, we also received Ayush Tech, a center of excellence in Ayush Tech supported by the Ministry of Ayush with an outlay of rupees 10 crore, has been established recently at the institute under the School of Artificial Intelligence and Data Science. Deep Tech Biodesign Center for Medical Technologies to bring innovation in medical technologies to our country. So IIT Jodhpur, in collaboration with AIIMS Jodhpur, has established a multidisciplinary biodesign center funded by Department of Biotechnology, Government of India, to train and nurture and transform the clinicians and engineers into the deep tech innovators in the field of medical and healthcare technologies. Now, IIT Jodhpur Jal Jeevan Mission Center for Sustainable Drinking Water. So this also sanctioned in 2022. So National Jal Jeevan Mission, Department of Drinking Water and Sanitation, Ministry of Jal Shakti has conveyed this sanction. And we have set up a JJM Chair Professor of the financial outlay 6 crore. MIT Center for Advanced Security Technology Development in Cyber Physical Systems. So Ministry of Electronics and Information Technology has funded the setting up a Center for Advanced Security Technology Development in Cyber Physical Systems in March 2022 with a financial outlay of 6 crore. There are also projects like Duchenne Muscular Dystrophy Centers funded by DST, Department of Science and Technology, around financial outlay of 5 crore to develop the affordable drugs for the Duchenne Muscular Dystrophy patients. There are also BioNest support from the BIRAC, and also we set up a TISC where around 40 incubation center institute set up. Apart from this, there are several major projects we received more than 2 to 3 crores, so I am not going through in the details. Finally, our faculty members received various prestigious recognitions such as DST Swarna Jayanti Fellowship, DBT Ramalingoswamy, DST Ramanujan Fellowship, INE Abdul Kalam Technology Innovation National Fellowship, ACRB Star Award, Wellcome Trust DBT, Early Career Award, ACRB Women Excellence Award, Google India Research Award, Ethics in AI Facebook Award, Varsik AI Faculty Award, DBT Innovative Young Biotechnologist Award, ACRB Sire Fellowships, DST Inspire Fellowships, and IGSTC Wiser Award, to name a few. Now, with this brief note, we strongly believe that in subsequent years, we will achieve our research goals with high targets, along with active support of all our faculty colleagues, staff members, and extremely talented students. We thank all IITJ community, and we look forward to receive your continuous support. So today, as a part of IITJ at the rate 15 event, we would also like to showcase some of the outstanding research contribution made by our colleagues, and we look forward to hearing from them. Thank you.
Thank you, Professor Ghosh. Now I would like to request the dignitaries to take their seats downstairs. As Professor Ghosh already said, we will now have short presentations of 15 papers with the maximum citations written by our current faculty members at IIT Jodhpur. To commence this program, I would like to invite Professor Sushmita Jha, Department of Bioscience and Bioengineering.
A very good afternoon to all of you, and thank you so much for giving me this opportunity to talk about our work titled Fatty Acid-Induced NLRP3 Picard Inflammasome Activation Interferes with Insulin Signaling, which was published in Nature Immunology. Now, this work talked about the link between a high-fat diet activating our innate immune system, which might lead to insulin resistance like we see in case of type 2 diabetes. So before I begin, I would like to introduce you all to innate immunity. Now, innate immunity is our first response to a pathogen or a damage or an irritant. So if you cut yourself, the first signs that you see of inflammation are because of innate immunity. Now, how does our body initiate innate immunity? We do that with specialized cells called as macrophages, which run to the site of this injury, and they can recognize the pathogen or damage or irritant, and they do so by recognizing the patterns of these molecules. So these patterns are called as pathogen-associated molecular patterns, damage-associated molecular patterns, or irritants. Now, how do these cells recognize these patterns? They do so with the help of specific pattern recognition receptors. Now, pattern recognition receptors are proteins on the surface of these innate immune cells called macrophages, which can recognize these patterns and initiate the immune response. Now, pattern recognition, therefore, helps initiate inflammation. The pattern recognition receptors that I'm going to talk about today are called as NLRs. Now, these NLRs can recognize patterns on the surface of pathogens or damage or irritants and can associate with other proteins, specifically in this case, ASC and procaspase 1, and form what is called as a multi-protein complex, which is an inflammasome. Now, this inflammasome is critical to our response to these danger signals. This inflammasome will lead to the production of pro-inflammatory molecules such as IL-1 beta and IL-18, which can signal to other immune cells and say, this is the site of damage, rush here. So the two molecules that are important here are IL-1 and IL-18. What is important to understand is that if there is a dysregulation of this signaling, it can lead to many diseases, from autoinflammatory diseases to autoimmune diseases to cancers. What we set out to find out is if the high-fat diet, when we have a high-fat diet, would that actually initiate inflammation, and could that lead to diseases such as type 2 diabetes? And our experiment was to take macrophages, which are these innate immune cells, and treat them with palmitate, which is a saturated fatty acid, and see if we see production of IL-1 beta or IL-18, which are the pro-inflammatory cytokines. And indeed we did. So we see that when we treat macrophages with these saturated fatty acids, we see increase in production of pro-inflammatory cytokines. When we take mice that lack these genes for these pattern recognition receptors, we see that they don't produce these pro-inflammatory molecules. That means these molecules are key to our recognition of fatty acids or saturated fatty acids. So we have this piCARD knockout mouse or NLRP knockout mouse, which will not have these key pattern recognition receptors and therefore not produce this immune response. But how do you prove that this in fact happens in the body? So to prove that, we used a mouse model where we injected this molecule IL-1 beta over a period of time and saw that there was in fact insulin resistance in case of a high-fat diet, which did not exist in case of mice that did not have IL-1 beta in their system. So if you see here, as we have IL-1 beta injected, there is insulin resistance, so blood glucose stays constant. It should actually go down over a period of time, but it doesn't happen. And in case of the IL-1 beta knockout mice, that is kind of stopped. So next, we wanted to test if these molecules work together and mediate insulin resistance, which is what you see in case of diabetes, where no matter how much glucose you intake, there is in fact less release of insulin. So finally, we were able to prove that saturated fatty acids in a high-fat diet can trigger inflammation. At that point of time, it was known that metabolic disorders such as obesity and type 2 diabetes are linked to chronic inflammatory states, but the mechanism by which these fatty acids are recognized and by which they trigger inflammation was not known. Our research was able to show that saturated fatty acids such as palmitate, but not unsaturated fatty acids, induce the activation of key inflammatory pathways. Now, this has led to greater understanding of diabetes. In fact, the blocking of this pathway is now currently used in the clinic, and these drugs which modulate these pathways are used for critical care for diabetic patients. Our lab works on uncovering inflammation, immunity, and tumor biology, and we actually collaborate with colleagues across the institute as well as at IIT Jodhpur to understand linkages between inflammation, immunity, and tumor biology. And we've been invited to submit our work in the NLR gene family and as a review in Nature Reviews Immunology recently. Of course, our research is supported by funding from many funding agencies, but this work could not have been possible without the continued support from IIT Jodhpur colleagues as well as staff members. Thank you so much for your attention.
Thank you very much, Professor Jha. I would now like to invite Dr. Appala Naidu to present his work.
Good afternoon, all. Today I'm going to talk about one work we have done during my postdoctoral study at King Abdullah University of Science and Technology. So in this work, we have synthesized nickel cobalt phosphide for water splitting. So I'm going to talk briefly about this work. So water splitting is one of the ways for producing hydrogen, and we have to supply energy for causing the water splitting. And there is a hydrogen evolution reaction and oxygen evolution reaction. And to expedite this process, we generally employ catalysts. And in general, platinum is preferred for hydrogen evolution reaction. And similarly, ruthenium oxides are employed for oxygen evolution reaction for improving the kinetics of those respective reactions. But they are expensive. So there is a necessity for looking for catalysts which are cheap. So one such compounds are phosphates, nickel phosphates, and they have demonstrated some catalytic activity. Now, here we try to see whether substitution of nickel with cobalt improves the catalytic activity of for water splitting or not. So here our experimental collaborators have demonstrated through plasma synthesis that it is possible to dope cobalt to nickel phosphate. So in the first step, they have used a hydrothermal process to produce nickel cobalt hydroxide. In the second step, they have employed pH 3 plasma to produce nickel cobalt phosphate. So this is the first part, and the advantage of this method is that it is a fast process, and it produces nanostructures which have atomic scale defects. And we have provided the theoretical support to this work. Through our first principles based calculations, we have shown that cobalt substitution would not change the metallic nature of the system. So nickel phosphate as well as nickel cobalt phosphate both remain metallic. And for hydrogen evolution reaction, first H2O should be adsorbed onto the cathode, and at the same time, it involves adsorption and desorption of hydrogen. And as you can see here at the bottom, the adsorption energy for H2 is not affected due to cobalt doping, and in fact, it is more preferred over when compared to platinum. If you could look at the Gibbs free energy of formation of hydrogen onto the cathode, it should be negative, but it should not be much negative. So as you can see here, cobalt doping reduced the delta G magnitude, and it is comparable to that of the platinum. Now, once we synthesized the nickel cobalt phosphide, we characterized their performance for hydrogen evolution reaction as well as oxygen evolution reaction. And we have here I am comparing the performance of nickel cobalt phosphide with respect to nickel phosphide, and for producing at a current density of 10 milliamps per cm square, we see the over potential of nickel cobalt phosphide to be 32 millivolts when compared to 93 millivolts of nickel phosphide. So it has reduced the over potential, and this is one of the lowest observed in case of transition metal-based phosphates for hydrogen evolution reaction. Similarly, the over potential for oxygen evolution reaction is also reduced in case of nickel cobalt phosphate to 280 millivolts compared to 340 millivolts of nickel phosphate. And in addition to that, you also see that we observe a stable performance of the device over 24-hour timelines in case of both hydrogen evolution reaction as well as the oxygen evolution reaction. So comparatively, the performance of the nickel cobalt phosphate is better when compared to nickel phosphate. Now, by using the nickel cobalt phosphate for both cathode as well as anode, we have studied the device performance, and we have seen that at 10 milliamps per cm square in alkaline medium, we see that the cell voltage required is around 350 millivolts. And also we have studied the stability of the device as a function of time, and we have seen the stable performance of the electrolytic cell within 24-hour tests. So to conclude this work, we have used plasma-assisted synthesis method for producing nickel cobalt phosphate, and similar method can also be employed for producing multi-transition metal phosphates or even complex phosphates, and it's also a fast synthesis process. And electrocatalytic performance of nickel cobalt performance is improved when compared to Ni2P, and also we have made the device which having wherein both cathode and anode are made of the nickel cobalt phosphate, and it has a comparable performance with the state-of-the-art electrolytic cells made up of transition metal phosphates. So this is about this work.
Thank you very much, Dr. Naidu. I would now like to invite Dr. D.K. Shashmal, Associate Professor, Department of Chemistry.
Good afternoon to all. First of all, I would like to thank Professor Chaudhary for inviting me to present this work, which was published in Science journal during my postdoctoral work at the University of Chicago and Argonne National Laboratory. The title of the work is T-cell Costimulatory receptor CD28 is a primary target for PD-1 mediated inhibition. So after COVID, probably we all know much better about the T-cell. T-cell is one type of white blood cell. It is a fundamental component in human adaptive immune system. So the basic function of T-cell is that it basically keeps us healthy. So whenever a T-cell finds a bad cell, for example, cancer cell in our human body, so it basically kills. So here I have given one example that one T-cell is killing 2 cancer cells. So actually this T-cell is not a human T-cell, it's actually engineered T-cell, which is known as CAR T-cell. It is a little bit powerful, it's an engineered cell, powerful than human normal T-cell. Now if you look at the interface between T-cell and antigen presenting cell, there are many receptor molecules on the surface of T-cell. There are many ligand molecules on the surface of antigen presenting cell. The main receptor molecule on the T-cell is known as T-cell receptor or TCR. And when it binds with its ligand, specific ligand, peptide histocompatibility complex class 1 or class 2, it gives a positive signal so that the cell become activate and start killing the cancer cell or any antigen presenting cell. There are a couple of important molecules on the surface as well, which is known as co-receptor molecule and immune checkpoint molecule. So one important immune checkpoint molecule is known as PD-1. So when PD-1 binds with PD-L1, it basically sends a negative signal towards the cell. However, co-receptor molecule CD28, when it binds with ligand CD80, it basically sends positive signal towards the cell so that it start basically activating and start killing any bad cell or antigen presenting cell. So our goal was to find out that PD-1 mediated inhibition, whether that signal pass through the main receptor molecule TCR or co-receptor molecule CD28. So if we look at the working model, how PD-1 suppresses T-cell signaling, usually naive T-cell, we don't have actually PD-1 molecule. So whenever TCR and CD28 bind with its respective ligand molecule, so the LCK starts phosphorylating the intracellular part, and at the same time, JAF70 starts recruiting on LAT. So, and then other downstream signaling starts, which also includes the calcium ion increase from 3 to 10 times inside the T cell. Now, when T cell become exhausted or activated, so the protein molecule SHP2, it basically phosphorylates the intracellular part of PD1 molecule. Now, at the same time, it actually dephosphorylates the CD28 molecule. So this is basically sending a negative signal. Now, if we look at how PD1 actually co-cluster with co-stimulatory receptor molecule CD28, so left-hand side, I have shown a video where right after the activation of T cell at the synapse, so T cell receptor microcluster starts to flow towards the center of the synapse, making that synapse even stronger. So if we look at the PD1 CD28 overlay, so here given red and green color, so the yellow color you can see that PD1 and CD28, they are actually in a same position. Whereas PD1 and TCR, they are not exactly in the same position. Now, if we look at the time sequence, we exactly see the same way that PD1 and CD28, they remain exactly on the same position, whereas PD1 and TCR, they remain in a different position right after the synapse formation. So now if we look at the stoichiometry, single molecule stoichiometry, how PD1 exactly bind with PDL1, so we find that PD1 and PDL1 exactly binds with 1-to-1 fashion. PD1 also binds with only single CD28 molecules. Okay, so there are several implications of this basic fundamental research in immunology. So I have shown probably 1/10 of the data. There are several other important data as well. But the basic implication of this study is that co-stimulation is important, not only the fundamental TCR and peptide MSC binding. The second one is that PD1 functions as a monomer. So the stoichiometry here plays an important role. So PD1 binds with CD28 and PD1 also binds in 1-to-1 fashion with PDL1. The other important thing is that PD1 and CD28, that fusion protein actually plays an important role. So this fusion, any immunotherapy, whenever there is an immunotherapy, the development requires the consideration of PD1 and CD28 fusion protein. In fact, one of my students who actually died last year because of cancer, he was taking that fusion therapy, PD1 blockade CD28 fusion therapy. The main important of this paper is that identification of CD28 as a primary target for PD1 mediated T cell inhibition. So this basically says that not only the primary receptor molecule, there is a co-receptor molecule which also plays an important role for T cell signaling. So this is the conclusion of this paper, and I would like to thank you for your time and attention.
Thank you very much, Dr. Shashmal. Partnership and collaboration are absolutely essential to furthering our research activities, and therefore it is our great joy this evening to sign an MOU between IIT Jodhpur and GATI Shakti University. For that, I would like to invite the Vice Chancellor of GATI Shakti University, Professor Manoj Chaudhary. Professor Manoj Chaudhary is also Professor of Electrical Engineering at IIT Jodhpur, and our Director, Professor Shantanu Chaudhary.
So, just want to highlight about this MOU. Gati Shakti Vishwavidyalaya, IIT Jodhpur, of course, everyone knows. And in this room, Gati Shakti Vishwavidyalaya is a central university that was established last year by an act of parliament to focus exclusively on transportation and logistics sectors. Transportation sector includes railways, highways, roads, waterways, inland waterways, ports, aviation, etc. So at this moment, this university, since it was notified on December 22 last year, so almost we are 6, 7, 8 months old, we are offering 5 BTech programs in this academic year in civil engineering, mechanical engineering, electrical engineering, electronics engineering, electronics and communication engineering, and AI and data science. Now these programs, we have, with the unique mandate that we have tried to differentiate our programs by offering specialization in each of the program. Specialization means 20% of the course content is related to specialization. For example, currently we are offering specialization in rail engineering, and we hope to offer specialization in other forms of transportation like highways and so on. Just to give an example, a BTech in electronics and communication engineering will have 20% of the course content as railway signaling systems, communication-based train control, and so on and so forth. Similarly, a BTech in civil engineering will have 20% course content on rail engineering, like how railway bridges are designed, railway tunnels are designed, railway stations and cargo terminals are designed. Of course, rest 80% course content will be all the fundamental aspects that goes into engineering. AI and data science being very, very important for the entire transportation and logistics sector, because whether you look at predictive asset maintenance or route optimization, these are all the classical problems, and the entire transportation sector looks at that. This university's primary driver was that in 2021, Prime Minister announced PM Gati Shakti National Master Plan 2021 to focus on multimodal connectivity and infrastructure building to progress towards a developed nation. Further, in 2022, National Logistics Policy was launched, which aims at cutting the logistics costs, which are currently 14% of our GDP, to approximately 8% of GDP, because that will make our products and services much more export competitive in the market. Therefore, we also offer 2 MBA programs, one program specialized in logistics and supply chain management, other MBA program specialized in transport economics and management. We hope that with IIT Jodhpur's assistance, of course I know as a family member of IIT Jodhpur, that we believe that together we can do a lot more in the many areas of cooperation that I already listed. Thank you so much.
Thank you very much, Professor Chaudhary, for introducing Gati Shakti University and for highlighting its focus areas, which I'm sure are of great interest to IITJ faculty members and students. Now I would like to invite Dr. Manish Narvekar, Associate Professor, Department of Electrical Engineering, to present his work.
Good afternoon, everyone. So I'm going to present this work briefly, which is titled Image Quality Assessment based on Gradient Similarity. This was published in Transactions on Image Processing. So as the title suggests, we are trying to develop a computational model to assess the quality of the image. And quality assessment in general is useful in the entire, you can say, multimedia delivery chain. So whether it's signal capture, whether it's processing of the signal, like we can compress the signal, we can transmit the signal, and of course, at the user side, we might render the signal. So in this entire end-to-end delivery chain, we require assessment of the signal, and this particular work was looking at a part of the problem, which was mainly from the compression perspective. Why is this problem so difficult, and what is it that we can try to do here is what I'm trying to, I'll try to explain here. So I've shown a couple of images here. These images are visually the same. You might not find any difference between them. So despite this projector, I think you might not find too much of difference between these 2 images. But actually, there is a lot of difference between these images. So if you look at it from a compression perspective, the file sizes are quite different. So there is something interesting happening here that, file size of 2165 KB is equal to 180 KB perceptually. So mathematically, they are not the same, but perceptually, there is something happening here that as humans, we see that both these signals are nearly the same. So how do we explain that? And this is, of course, a well-studied problem in vision, and it's called the masking phenomena. If we want to assess quality, we would want to incorporate this masking phenomena. That's the main goal of this particular work here. I'm going to take another example just to sort of drive home the point. Again, a couple of images. If you look at this particular image, you can probably see a lot of distortions as compared to this image. But then again, the interesting thing is both the images are compressed at the same level using JPEG 2000 compression algorithm. So what we find here is that despite having the same compression, these two signals have different visual quality. And in fact, we did a subjective test for that, and 30 human subjects rated these two images on a scale of 1 to 5. 1 means it's like very bad image or very poor quality. 5 means it's perfect quality. So as you can see, this one is rated worse as compared to this, despite the fact that we are applying the same compression levels. So just like the previous example, we have this case that despite using, say, a compression level of 0.6, we are not getting the same quality. So this is, again, the masking phenomena at play. So essentially, if we look at image quality assessment, it's a multidimensional problem. There are several aspects to human vision here, but this particular work focused on this masking phenomena. And the main challenge was, how do you actually model this masking? So it's a well-studied topic, but then the challenge is, how do we really accommodate this phenomena using a computational model? So again, this masking happens at various levels. It can be amplitude masking, frequency masking, orientation masking, and so on. So I'm skipping those terms, but in general, if we accommodate this phenomena of masking, then we can develop a reasonable quality assessment model. So just to summarize, this is what I wanted to do. We wanted to develop a computational model such that these two things should happen. Like these two images should be given the same score or similar score. Likewise, these two images should be given different scores, despite these images being similar or different in their compression levels and different other aspects. So this sort of computational model development is what this particular paper targeted. Again, the details of the algorithm, basically it was based on the idea of gradient. So gradient, I think most of us probably know. It's a basic idea in mathematics. It's closely related to the idea of frequency in signals. So what we did was, we took this idea of gradient, but then I also mentioned this point about masking. So the gradient information in this signal was actually modulated or modified by the masking properties of the human visual system. So the details I'm skipping here for sake of time, but essentially this was the main idea or the novelty of this particular work. Again, as I was mentioning, masking can happen at different levels. You can have luminance masking, contrast, and structural masking. And again, there are certain other aspects of masking that happen as far as human visual system is concerned, or in general, human perception is concerned. I'll just sort of end this presentation by just highlighting that this is one of the most cited papers as far as image quality prediction is concerned, and it has been widely used in the past, and even today it is being used in certain other contexts where we are trying to measure image similarity. So it can happen during image reconstruction, it can happen in MRI reconstruction, and so on and so forth. So essentially the idea remains the same, but then the applications can actually evolve. And as I mentioned here, this also remains one of the benchmarks as far as image quality assessment is concerned. Thank you for your time.
Thank you very much, Dr. Narvekar. Now I would like to invite Professor Ajay Agarwal, Head of the Department of Electrical Engineering, to present his work.
Thank you. So this topic is high performance, fully depleted silicon nanowire, which was having a diameter less than 5 nanometer. And these nanowire-based transistor we realized for the first time, which was gate all around CMOS devices. So this work was done while I was in IME Singapore. So the work focuses on some of the novelties here. So we realized this gate all around transistor, both N-type and P-type field effect transistors were realized, and they were realized on 8-inch wafers, 8-inch SY wafers. And for this purpose, the gate, this nanowire channel diameter was less than 5 nanometer in this paper. Later on, in fact, we demonstrated up to 2 nanometer transistors operational into circuits also. So this was the lateral formation of the nanowire. And the technique here used was lithography, optical lithography. So that was the novelty here. We use optical lithography, but we use phase shift mask. And there was another technique which we used to reduce the dimension of these fin-fatty structures initially. And later on, the limitation of the dimension of this channel was using self-limiting oxidation. So it was a very well-controlled process, and we optimized this process, and we were able to get on 8-inch wafer, entire wafer at one point to another point, all very controlled dimension using self-limiting oxidation. And on this wave, the dimension, the length-wise, if you see, the wires were of the length of something like 140 nanometers to 1000 nanometer, that is 1 micron. These are the couple of characteristics which are the main thing. What we found that we were near ideal sub-threshold slope, which was around 63 achieved. I'll show the graph here. 60 is the ideal number. Drain-induced barrier lowering was happening there, and with the I on and I off was around 100. So these were some of the electrical characteristics, and the drive current was 1.5 and 1.1 or 1 milliampere per micrometer length of these wires, and this was achieved in 180 nanometer for both N-type and P-type. And this was on the threshold. So I'll just show some couple of results in slightly more detail. So the figure on the top shows these are the layout of different masks. So we were making a fin structure first, and this dimension control was done using two tricks. I will say that one is a phase shift mask, and another thing what we were doing, we were reducing the dimension by a controlled reduction using some etching of this fin photoresist, and then self-limiting oxidation. Image 2, if you see on the top, the B image, so this is the fin which was realized, and this is 1000 nanometer long, and you can see the fins very well controlled of 50 nanometer. There is no EBL used here, and the height was 200 nanometer because the SY wafer, the device silicon was 200 nanometer, so it is 200. Next, if you see the figure number C, you can see there is a wire formation here. So this is after the self-limiting oxidation. There is a wire here, and then we were depositing a controlled way the silicon oxide, and next you can see how we were putting gate electrode using amorphous silicon and a controlled doping of this amorphous silicon. And the TM image, which is a cross-section of this nanowire, in the center you can see a less than 5 nanometer dia silicon channel. And around that 9 nanometer is gate oxide, and outside all this, the one side is somewhat dark, another, this is amorphous silicon, which is highly doped, which is working as a gate, and is fully covered. So that is what its structure was achieved using technological development at that time. These are the characteristics, nothing much to say. Here you can see the slope 63, which was achieved in NMOS. These are the other characteristics I talked before, and I on and I off, and we achieved more than 100 here. This is another interesting result that in both NMOS and PMOS effect of this substrate potential is not existing. So there is nothing. And the same wafer we were having a planar device also, P-type, N-type, and we can see subsequently that there was the effect of gate potential. So this was the work done that time. And thank you very much.
Thank you very much, Professor Agarwal. One of the activities that we undertook during the Foundation Day celebrations to show that creativity is not something which is narrow and restricted but should be inclusive and open to all was a phone photography competition which was open for all members of the IIT fraternity, not just faculty and students and staff members but also family members. And it is our privilege now to announce the results of the phone photography competition. We'll do it across the course of this event. It was a matter of great joy to receive more than around 150 entries, of which 65 are exhibited upstairs, and I'm sure you might have had an opportunity to see them. We will be honoring 15 winners, obviously 15 because it is 15 years of IITJ. I would like to request our director, Professor Shantanu Chaudhary, to present the first 5 awards. I would like to invite on stage Anandita De, Chandra Veer, Shubham, Ayan De, and Rajan. Chandra Veer, Shubham, Ayan De, and Rajan. Thank you very much. Now I would like to invite Professor Mitali Mukherjee, Head of the Department of Bioscience and Bioengineering, for her presentation.
Good evening, everyone, and happy Foundation Day. And I would like to thank Professor Chaudhary to invite me for giving this talk, which I did as a part of a consortia. It was called as a Hugo S&P, Pan-Asia S&P Consortia. And I led the team from India, but it had participation of 10 countries, and we worked across, studying 2,000 people across 72 populations. So basically, the paper is very old. I would just like to say why we got into this, what we got out of it, and how do we use this information. So as we all know, humans have started moving from Africa 100,000 years back. They have colonized different parts of the world, inhabited different regions, climate, food, etc. And in India also, it's known that it's a global melting pot of human diversity. There's been archaeological evidence of human existing many years back, and also there have been many, many recent invasions. So all these are facts, and how do you know that? So basically, some history, some archaeology, and you start to reconstruct. So in today's day, genomics is one such tool which allows you to reconstruct human migration, understand where we come from, how we have moved, how we have mixed. So all about populations you get to know by using this tool of genomics. And this is very important because we need to know not only our history, but how mutations move across populations. So it is also important for health, large number of aspects. You would have heard about precision medicine. So that's the basic of that is knowing populations. For example, India has major linguistic lineages, thousands of endogamous populations, multiple languages. So if you ask who is a reference Indian, it's very difficult. So during this time, we were doing the Indian Genome Variation Project, basically to know how many populations we need to call who is a reference Indian. And this was, I was the convener of this Indian Genome Variation project, which built the first map of India, that how, if populations speak Indo-European language, they speak Dravidian language, they speak Austroasiatic language, they speak Tibeto-Burman language, are people who speak the same language more related to each other, or people residing in the same geography more related to each other, how are they related? So this is the map which we built. I'll not get into the map, but the interesting aspect which we could get was that we could actually build overlay it with disease prevalence and try to see whether these maps tell us something. So for example, this map, you see there's a red color, and this is with respect to a particular gene. If you have a variation in this gene, which is a receptor for HIV, then the virus cannot gain entry. Turns out that only this part of the world, country, is protected from HIV virus because of having this kind of a mutation. So this is because this is the entry from the western frontier, and these populations in the Europe are more protected from HIV, and since the population came from there, the populations here are more protected. So we wanted to know how we are related to different populations of the world, and that's why we got into this Pan-Asia project. We wanted to know how people in across Asia are more related. And this was a major project. For the first time, countries which do not talk with each other across boundaries got together in Singapore, and we did all the work in India. We were just starting genomics in India, and we were able to have a very interesting result across Asia, where it showed that if people resided nearly in the same geography and spoke the same language, they were more related to each other. So this is a phylogenetic tree, where populations which are closer to each other are more in the tree closer. And so this is Japanese, then Chinese, Thai, Indonesian, Malaysian, and all. And you can see that this is a Yoruban population, the African population. If we anchor that, all the Indians are here, and then after that, all the Southeast Asian population. So if we plot the same thing on a principal component, then you see all the Asian populations get separated if you have the African population. We remove the African population, other populations start to split, and these are European, Indian, then Uyghur in China, and then Tibeto-Burman in India, and then all the East Asian population. If we remove the Indian population, then we start having other separations. So this is just like the geography, how the populations segregate. We can actually trace that. But it gave rise to some very interesting hypotheses, which is why it came to science, that long back people thought that from Africa, people have moved to the Americas through different, meaning different times, through multiple routes. But what came out from our study was that India is one of the major seat of all the populations coming in, and from there, every population, all the populations radiated all across the country. So India is the origin of lots of Asian population. So if we now, what is the advantage is that now if you have such kind of a data, you can start to integrate all the data across the world if you have that. So we did it with the Indian population. So these are all the world population. This is in China, this is Middle East, this is Europe, this is Africa. If you take Indian population, then you can see Indian populations line across all parts of the world, which actually tells that India is a melting pot of human diversity. Every population is in India, and any study you want to do for world can be done in India, provided you have the proper reference population. So this work is in the Calcutta Museum. I was very, recently a student of mine visited the museum in Calcutta, and he said that the work which we've done in the Indian genome as actually featured. And how this is important, this is the last slide, is that during COVID, we all found that large number of people in countries had different prevalence of the disease. Dharavi was affected, but not those many people died as in America. So there is something to do with the population, something to do with the behavior, and all of it in some way is related to the genetic makeup we have, and we need to understand that genetic backdrop in order to have a proper intervention strategy. This book is a very interesting book. It's one of those books now which people are delving with all such kind of information to be able to understand populations, understand ourselves, and have precision interventions. So thank you all.
Thank you, Professor Mukherjee. I would now like to invite Dr. Shahab Ahmed, Associate Professor, Department of Physics, to present his work.
Okay, so good afternoon all. It's a difficult task to talk after Professor Mitali Mukherjee. So I'm thankful to the organizers for giving me this opportunity. The paper which I'm going to talk about is about light-emitting diodes. We made use of the solution processable materials known as metal halide perovskites, and this was published in journal Nanoletter. This work I performed during my postdoctoral time at the University of Cambridge. So let me just quickly briefly introduce the material, and then I'll talk about the device structure. The material is having a general formula of ABX3, where A stands for the organic, which sits in between or at the center of the cube. It has a cubic structure. This A can be methylamine, formaldehydamine, or can be an organic material like cesium. And then there are octahedra, which are made up of metal halides. So these metals can be lead, tin, and so on. These are mostly divalent metals. And then X can be halide like iodine, chlorine, bromine, and so on. So that forms a cubic phase. And when we take this material, because of the structural flexibility, we can tune the optical property and the structural property, and also the optoelectronic property of these material, which means that we can use this material for solar cell applications. We can harvest the sunlight and convert it into electricity. And we can also use it as a material where we can recombine the electron and holes, and we can produce light, which means we can use them for light-emitting diode applications. So this device structure shows a typical schematic. What we have in light-emitting diodes is basically we have an electron transport layer and we have a hole transport layer. The purpose of these two layers are to inject electrons and holes in the emissive layer, which is composed of this perovskite material. So both electron and holes, they come from different electrodes, and they get recombined in this emissive layer, and they produce emission, which is known as electroluminescence. So the advantage what we get from these devices is that they are super thin. We can imagine that this entire device is almost like 500 nanometer. And just let me brief that the thickness of human hair is around 70,000 nanometer. So it is that thin. And if we compare it with the conventional light sources, for instance, the cathode ray tubes or plasma-based light sources, they are very bulky. They have different advantages, but when it comes on the size and the compactness, the LEDs are much more advantageous. And that is the reason why we use these devices or the display devices in compact electronics, for example, mobile phones. So we have the gallium nitride-based LEDs, which are very compact, very efficient. But this work talks about the use of perovskites, which are the upcoming or the next generation materials. They are low cost because they make use of very low cost raw material. They can be solution processed very easily, and they also have advantage in terms of the crystallinity. When you process them by using different solution processing techniques, you can make them highly crystalline. So they have certain advantages. So this schematic here shows commonly used electron transport and hole transport layers. I will not go into much detail, but just to let you know that what we know from our semiconductor physics understanding, that when we excite the electrons, when the electron goes to this excited state, it becomes free. So it goes into the conduction band, and then from there, if we provide an appropriate interface, it can be easily de-excited to a lower energy state. So it can be collected or it can be injected to an emissive layer. Similarly, the hole, when it is in the valence band, it is a free hole, provided that it has been injected. So it can easily be collected in an emissive layer. So which means that we have some set of materials for ETL and we have some set of material for HTL, and we just have to work with the suitable perovskite film to find the cascaded energy band gaps. And once we do that, we can actually realize the material or the device. So as I mentioned that this work I started during my postdoctorate time. The novelty of this work is that this was the first demonstration of blue LED. The blue LED is important because with the blue LED, we can actually realize all the possible colors from green, red to in fact NIR. Because what happens nowadays is that we use gallium nitride, and then on top of gallium nitride, we coat the desired phosphorus material to produce the desired emission, and that is how we get the other colors, red, green, blue, and so on. So the blue is very interesting. It's very promising for different, to generate different colors. So what we have done here is that we have tuned the electroluminescence from blue to green, and by changing the halide composition of like bromine to chlorine. So the X here shows the ratio of bromine to chlorine. Okay, and this is the spectra for the photoluminescence. It shows that how, with the change of the elemental composition of halides, we can tune the emissions, the photoluminescence from green to blue. And when we make the light emitting diodes out of it, we can tune the electroluminescence in the same fashion. I will just try to give an overview of the characterizations, what we performed on the thin films, and then also I will talk about the devices. The absorption spectra, as I mentioned, that when we change the halide composition, the band gap changes, and that was the objective of the work, that first we tried to tune the band gap, and then we convert those materials into devices, and then we try to see the electroluminescence. The study here, the first figure here shows the absorption spectra. It talks about the band gap of the material. The second spectra here is also an absorption spectra, but this is extracted by calculating the absorbance by making use of the photothermal deflection spectroscopy. It's a more accurate way to estimate the absorption. When we perform the UV visible absorption spectroscopy, we actually count the number of photons which got absorbed by the material, and then we see that how many of them got transmitted, we find the ratio, and we find the absorption. But when we perform the photothermal deflection spectroscopy, we actually try to see the amount of heat which got absorbed by the material. So which means that when you talk about heat, this measurement becomes more accurate because we try to avoid the scattering of the light. So this provides a much more accurate estimate of the absorbance. And then we also saw the material which has the highest content of the bromine has the longer lifetime, which means they can stay in the excited state for longer lifetime, which means they can travel a longer distance within the film. Then talking about the devices, this is the device structure. This is the scale bar, 300 nanometer, and this is the entire device thickness. So here we have the CBP as a whole injecting layer or whole transport layer, and magnesium doped zinc oxide as electron transport layer. And the material what we have used is the methylamine, lead bromide, and lead chloride based perovskite material. And based on the band gaps, we have seen the range of electroluminescence. So you see this one is 100% chlorine. The best part of this work is that we managed to get a very narrow line width. Line width is the width of this purple color spectra, which shows that the line width is 5 nanometer, which means that it is highly color pure. Okay, so which means that when we talk about this blue, it is the purest form of the blue, and that is very important because when we see with the organic LEDs, or if we compare with gallium nitride LED, they have a very broad FWHM, which means they are not that color pure. And yeah, so these are the other measurements we tried to see. The turn-on voltage. Turn-on voltage was matching with the band gap of the material, which means that the charges are balanced and there are not much losses. Just to brief you that the recent advances happening with the work what we started was about blue LEDs, but now people are talking about the advanced phase of the perovskite material known as Rudelston-Popper phase, where we can tune the band gap just by changing the number of inorganic layers. So we don't have to change the halide content. We can just change the number of inorganic layer. And we can see the electroluminescence can be tuned from blue to red. So with this, I stop here and I thank all of you for this opportunity and for your attention. Thank you.
Thank you very much, Dr. Ahmed. I would now like to invite Dr. Devendra Singh Negi, Assistant Professor, Department of Physics, to present his work. I'm sorry, Department of Material Sciences.
Good afternoon to everyone. First of all, I would like to thank to our Honorable Director and all the committee members for giving me this opportunity to present my work today. My work was published in Chemistry of Material, and the title is High Thermoelectric Performance and Enhanced Mechanical Stability in P-type Antimony Doped GET. Now, in this work, I have basically shown that how we can engineer the thermal efficiency of a thermoelectric material by creating different kind of microscopic structural feature in thermoelectric material. So I'm from Materials Engineering Department, and for this work, I have used one of the India's first double aberration corrected microscope and various data processing method that I'll explain in the upcoming slides. So as we know that, as our human civilization is developing, the demand for the energy is incessantly increasing. In fact, in the few decades, the demand for the energy has shot up exponentially. Therefore, we are looking new energy resources, and due to the environmental issue, we are looking for the green energy resources. It's good that we are looking for new energy resources, but also we should best optimize and best use the energy resources we have. Therefore, we should use our energy resources in such a way that we use every waste of the energy. Mostly in the industrial scale, the energy gets lost in terms of the heat dissipated. So we required some material which can convert these waste energy in terms of electric energy. In this context, thermoelectric materials provide a solution. These materials which converts the temperature gradient in terms of electric potentials. The efficiency of these thermoelectric materials is measured by a quantity which is known as the figure of merit, which is proportional to its electronic conductivity and inverse proportional to its thermal conductivity. Therefore, a delicate balance between its electronic conductivity and thermal conductivity governs the efficiency of these thermoelectric materials. And it's not very simple that you just create a temperature difference and these materials will give you the electric potential difference, because the thermal efficiency depends on various atomic parameters such as charge, lattice, spin, and orbital. For instance, if you have two different spin on the adjacent atom, the electronic propagation will depend on what is their orientations and what is their nature. Therefore, the property of a thermoelectric materials depends on a subtle interplay between these atomistic parameters. And therefore, our task was, can we design a material in such a way that we can enhance the efficiency of these thermoelectric material. So in this task, we have taken a material called germanium telluride. A PBTE, or lead telluride, is well-known thermoelectric material, but it has lead at its component, which has some environmental issue. So we thought that, can we grow an environmental friendly thermoelectric material? GETE is also a thermoelectric material, but its figure of merit is around 0.8. So we were thinking that, can we engineer the material in such a way that we increase its efficiency by means of a doping. So we have doped antimony from 2% to 10% this material. And our structural characterization first shows that it undergoes a structural transformation. At 573 degrees Celsius, it undergoes from a rhombohedral structure to the cubic structure. Now, cubic structure has a more symmetry, therefore it can provide a more degenerate energy states. We have also seen the band gap, and we found that with this doping, the band gaps significantly reduces from 1.3 to up to 0.8 EV. And with a different cooling and heating, we found that this structural phase transition exists. Now, these are some of our main results. In fact, these nanostructurings gives the idea that how we can basically tailor the thermoelectric properties. So we found that there are a lot of microstructure are taking place in this material. The first one is known as the herringbone structure, where you can see an alternative black and white stripe. Now these patterns arises in the materials when the Friedel symmetry breaks in a non-centrosymmetric crystals. We have also taken the HRTEM, and we found that it's indeed a rhombohedral structure. Then we found it has a twin boundaries, which happens because it undergoes a structural phase transition. Now, this zoom image shows that how these sharp boundaries emerges in these stripe patterns. We have seen the inversion boundaries also. We have seen a defect layers where there is a tellurium defects persist. There was a microscopic precipitation was forming. So we were witnessing a lot of structural features, and when we did the thermoelectric measurement, we found that it greatly enhanced the figure of merit of this material. Now, we try to understand that why this is so and how these microscopic structural features are helping to enhance the figure of merit in this material. Do this microscopic structure has any role to enhance its thermal efficiency? Now, these microstructures basically provides a grain boundaries which act as a scattering center for the phonons. These phonons basically transport the thermal heat in these materials. So when these phonons scatter on the boundaries of these microstructure, the thermal conductivity reduces. Now, in the figure of merit formula, you have seen that this thermal conductivity is inversely proportional to the thermal conductivity. Therefore, if we can reduce this thermal conductivity, then we can enhance the figure of merit or the efficiency of these materials. And therefore, we witness the high enhancement in the thermoelectric properties. Here are the thermal measurements. So you can see that first it shows a reduction in the electronic conductivity, but there is a significant increasement in the Seebeck coefficient of this material. The GATI parameter or the figure of merit parameter shows a very enhanced figure of merit which goes to 1.85 at 725 degrees Celsius. Now, the GETE material, germanium telluride, the parent material, has a figure of merit 0.85. Now, with this doping, we can enhance up to 1.85, which is a remarkable feat. Also, you can see that there is a reduction in the thermal conductivity. So, we concluded that with these microscopic structure formation, we can reduce the thermal conductivity due to the phononics scattering on the boundaries of these material, which helps to enhance the figure of merit or the thermal efficiency of these thermoelectric material. So the key point for this work was that we have grown an environmental friendly thermoelectric material. We have given an idea to the thermoelectric material community that if we can engineer these microscopic structure at nano and mesoscopic scale, we can basically increase the thermal efficiency or figure of merit of these thermoelectric material, which have inspired the community of a thermoelectric material, and that's why this paper got almost 300 citations. So with this, I would like to thank you.
Thank you very much, Dr. Negi. Now I would like to invite Dr. B.M. Krishna from the Department of Physics to make his presentation.
So, very good evening, everyone. Thanks for giving me this opportunity to present my well-cited work. So, today I am going to talk about biosynthesis of silver nanoparticles and its applications. So, myself, Dr. B.M. Krishna Marisarla from Department of Physics. So, first, I will start with motivation and synthesis methodology. So, then I will discuss different characterization techniques to identify the nanoparticle formation and their crystallinity and particle size distributions. So later, I will discuss nonlinear optical measurements for their applications towards optical imaging, and finally, conclusions with certain biological applications. So this work was published in 2010. So till then, there is a lot of methodologies to prepare the silver nanoparticles. So there are various routes with the chemical method. So that means they leave a chemical residues which are toxic in nature, so which are not suitable for injecting into any biological system. So this is a very big disadvantages to use the surface plasma resonance of metal nanoparticles. So we attempted to prepare silver nanoparticles using bio route. So here I will discuss about the biosynthesis methodology. So where we have taken homegrown coriander leaves, as you see here. So they are well cleaned and we boil for a couple of minutes, roughly 5 minutes, to extract the leaf solution. So this extract act as a reducing agent to reduce the silver ions from the precursor solution. So this extract is added to aqueous solution. The aqueous solution is maintained at 33 degrees centigrade, which is for thermal annealing. So now the precursor solution AgNO3 is injected slowly, such a way that the particle formation can takes place by reducing the silver ions. So after 10 minutes, what we observe is the colorless precursor solution is changing towards the yellow color. So that is the first identification of the nanoparticle formation. So this is a very simple method and the fastest method until 2010. So now this method is following by many researchers. And the many advantage of this method is the nanoparticles which are formed, which are very, very stable, and still we observe more than 2 years, the nanoparticles are no agglomeration. So that is the best method till date. So now we identify their crystallinity and the particle distribution using XRD and TM measurements. So as you see from the XRD, you have a high crystallinity peaks where the narrow peak tells you that the nanoparticle formation, and you can see the spacing of the TEM images, the high crystalline nature, and you can see SCD pattern. And this particle distributions varies from a couple of nanometers towards the 60 nanometers. So you have a various particle distribution, but average particle size is 26 nanometers. And now the immediate observation of this nanoparticle conformation by done using UV visible spectroscopy and FDR spectroscopy. So as you see here in the UV visible, as the synthesis timing is changing, we can tune the particle size. As you can see from A to E, the curves are actually blue shifted. So that means we can actually tune the particle sizes accordingly with your synthesis rate. And then we did NLO measurements, so nonlinear optical measurements using open aperture and closed aperture G-scan techniques. So where we can see here, the insert figure shows that the precursor solution, that means at 0 time, so we don't see any nonlinear absorption. The plot says nonlinear transmittance versus the G position. So as you see here, at 0 time scale, there is no nonlinear absorption. But these nanoparticles show very strong nonlinear absorption. And also in the down figure, you can see it has a nonlinear refractive index. So nonlinearity in the material is very useful for various communication devices and for various nonlinear optical devices. And this material shows, this nanoparticle shows a strong nonlinearities. And then we further examine the radiation limiting characteristic or capabilities of these nanoparticles using this technique. So we use high power laser and shining on these nanoparticle systems, and then we observe how this shows certain capability of radiation shielding. So now you see here on the right hand side figure, we drawn output fluence versus input fluence. That means at low powers, you can see that all the light is transmitting. At low intensities, it allows the complete light to pass through, and at higher intensities, it is clamping all the light. So that means it is not allowing some certain range of intensities, it blocks all the high intensity power. With that, I would like to conclude with the methodology what we developed is very rapid, fast, stable, and eco-friendly, and is also easily scaled up technology. So the nanoparticles which are formed using these plant extracts are very stable. So more than 2 years, you don't see any agglomeration, and we can control the size of the particles and monodispersity with the controlling synthetic parameters such as pH, temperature, incubation period, and mixing ratio. So we observe a strong nonlinearities in these nanoparticles, which are actually comparable to the other chemical routes, and sometimes these are higher than the chemical routes. So here I show certain applications for biological applications, because these nanoparticles, metal nanoparticles, are very important to inject into biological systems for like drug delivery, so that you shine a laser light, and the controlled drug delivery can be possible by using these nanoparticles will absorb the light and it dissipates the heat so that the drug can be delivered. And also it can act as a biosensor, and we can do the photothermal therapy, and we can treat the cancer cells using these nanoparticles, give the heat treatment. So with that, I thank you all.
Thank you very much, sir. Now I'd like to invite our Deputy Director, Professor Sampath Raj Vadera, also of the Department of Physics, to present his work.
Good evening. This is micro-absorbing properties of thermally reduced graphene oxide butadiene rubber composite. This work was done in DRDO in 2012. And basically, when we talk of stealth aircraft, what we are looking at is that, the aircraft should not be seen by the radar or should be seen at a very longer distance. And so there are two techniques. One is shaping, which I have shown here that, if you don't have shaping, whatever radiation goes comes back to radar. And if you do the shaping, next figure, if you see on the right, it says that most of the radiations will be reflected in other direction and it will not come back to radar. And that's one of the ways, but shaping cannot do everything. So what you need to have is add-on materials. And these materials have to be applied on the surfaces of the aircrafts, or they can be in the structure part also. So they can be either structures or coatings. And what commonly used materials means you have to have materials with magnetic properties and dielectric properties. Because you have got electromagnetic radiation, it interacts with electric field or magnetic field. So ferrites are one of the conventional materials which still are being used. Dielectric materials are carbon black, conducting polymers, carbon nanotubes. What important requirements when you are talking of these materials to be applied on aircraft systems? They are airborne systems. They have to be light in weight. They should be environmentally stable and should have high microabsorption and broad frequency range they should be working in. So what we saw is that reduced graphene oxide has got those properties like two-dimensional material. It's ultra lightweight, environmentally stable, and high values of electrical conductivity and system level applications. These are two red, I say, they are challenges. Because when high electrical conductivity is there, reflections are going to be high, impedance matching is going to be a problem. And then when it is pure material, how do you apply on the aircraft surface? While people were working, this graphene was discovered in 2004, and mostly people were working on to establish the material, its characteristics, properties, and all that. While we were working in, micro-absorbing material, we realized that this material can be really useful for micro-absorption. Particularly, you can have very lightweight micro-absorbing materials. So what we tried, that we can try to see that if we can embed this material into a rubber, which is again a lightweight, then overall the material or micro-absorbing material which you will get will be light in weight as compared to any other material. Another advantage we saw in case of graphene, reduced graphene oxide is that you need to put very low percentage of doping. When we say ferrite, we put around 40 to 50%. If you say even carbon black and all these materials, you have to put very high percentage of the materials. And then when you develop the materials, you have to characterize those materials. So we did FTIR, we did X-ray diffraction, we did Raman spectroscopy measurements. These are generally used techniques for the characterization. And then scanning electron microscopy, where you can see very clearly layered structure of reduced graphene oxide. This is where it indicates, yes, it is a reduced graphene oxide. It has got layered structure. And then last slide, reflection loss properties we call it. And it gives a reflection loss of around 40 dB and give very good, maybe around 4 to 5 gigahertz of bandwidth. So it is a lightweight material with very good micro-absorbing properties with very low loading. And this was perhaps the first report wherein anybody reported using reduced graphene oxide as a composite for micro-absorption. And then, since then, there has been a lot of literature on this particular material, and that's why it is highly cited paper. And I would like to acknowledge my DRDO colleagues who were there, who had worked on these things, Vivek, Anuj, Manoj, Lokesh, Jani, Dr. Narendra Kumar, who was my predecessor director, and of course DRDO. Thank you. I think I have finished in time.
Thank you very much, Professor Vadera. Now I would like to invite Dr. Jitendra Jadhav to give away the next 5 prizes for the winners of the photography competition. I'd like to invite on stage V.N. Neerav, A. Jyoti, Mansi Mukherjee, Puru Raj, and Rajat Parikh. Mansi Mukherjee. Shashikala Avasti. Thank you. Thank you very much, sir. Now I'd like to invite Professor Gaurav Bhatnagar from the Department of Mathematics to present his work.
Good evening to all. Myself, Gaurav Bhatnagar, I belong to the Department of Mathematics, and today I'm going to present this work which is very close to me. The reason being is, this is the initial work which I have done long back in 2013 when I joined IIT Jodhpur, and eventually it became my first publication with the IIT Jodhpur affiliation, and gradually it became one of my most cited publications. And it's all about the directive contrast-based multimodal medical image fusion in NSCT domain. So the motivation of this work lies in this particular slide, which summarizes the different modalities of medical images which are available to us, like we have the CT image, MRI image. So all these modalities are having the different philosophies and the requirement. For instance, if we talk about the CT image is going to highlight the dense structure in the body like bones or body stones and so on and so forth. On the other hand, MRI, PTs or SPECT are going to be very useful for highlighting the tissues present in the body. So whenever you take a modality of the human body in the imaging system, so you are going to get the contrasting information. So every modality is going to give different kind of information out of it. So for a better diagnosis, it is pertinent to have the integration of all available information in all the modalities into a single picture so that the complete overview of the disease can be obtained. So for this particular motivation, we have proposed a fusion framework for the different medical images. So this is going to be the pipeline for the same, where we are going to take the panchromatic image, which is going to be MRT1, T2 images, and then multispectral image, which is going to be the PET and SPECT images in the medical domain. So idea is we just want to first convert our medical image or multispectral medical image into a domain which is very close to the human visual system. So we have chosen the CIE LAB color space, where we projected the given image, and then this L channel, which is called the luminance channel or brightness channel for the image, can be fused with the MR image. And for the fusing, we have devices, device technique, where we are going to use the non-subsample control transform, which essentially decompose the signal into the low frequency and the high frequency component in different directions. So then we are going to pick up the low frequency component from the different images or different inputs, and then fuse it using the phase congruency feature, which is going to be a method by which we can find out the salient features out of the medical images. And the high frequency component, we have defined the concept of the directive contrast feature, which is going to take the contrast concentrated on the different direction of the NSCT domain. We will capture those information. Basically, it's going to be the texture information present in the medical images, and then try to fuse it to locate the actual area or the region where the disease is actually going to occur. So the practical validity of this particular work we have done on the 3 different clinical examples, where the very first case is a case of a 70-year-old man having the Alzheimer's disease, and the second case is going to be the case of a 65-year-old man suffer from the subacute stroke, and the third case is of the 51-year-old woman having the recurrent tumor. So after having the analysis, we have concluded that the proposed technique is efficiently providing the information of the disease of a person or the regions present in the human body, which is analogous to the decision taken by a standard medical practitioner. So with this note, I will say thank you for providing me this opportunity, and I will again, after this, we have done multiple work in the same direction, which are published in the different publications, and some of them are again in the bouquet of my highly cited publications. So thank you very much.
Thank you very much, Professor Bhatnagar. Now I'd like to invite Professor Jnan Bandyopadhyay from the Department of Electrical Engineering to present his work.
Good afternoon to you all. At the outset, I thank Professor Chaudhary for inviting me to present on this, to talk on this paper, and also Professor Ghosh to organize this particular event. I will be touching certain important points of this paper, that implementation of the super twisting control, second order sliding mode control, and what is the importance of this particular paper that I will be discussing in a very short time, in the coming 6 minutes. Actually, this variable structured system and sliding mode control was originated in the then Soviet Union in 1950s. The idea was conceived, the stabilization of a system using discontinuous control. It was not thought before in 1950s by these two people. One is the Emelianov, another is the Utkin. He was given the title academician, which is cabinet minister rank in the Soviet Union, and he's the Utkin. He got the highest scientific award, Lenin Award, in Russia to invent this idea, the variable structured system and sliding mode control. So this idea was confined in Soviet Union until a paper published in English literature in IEEE transactions, control transaction, in 1977. And then it sparked research interest all over the world. After this paper, and then, it has become one of the accepted technique for the robust control design methods. However, it has certain drawback. It was working very nice in practice. It was it was working very nice in theory. Is a differential equation. The right-hand side is continuous, so it has a Filipov solutions, and it was working very nicely. But when it was implemented in practice, like an aircraft, the elevator, or a missile in a fin, then it chatters, the discontinuous control. In theory, there was no problem, but in practice, there was some problem, the applicability of this idea in practice. And then somehow it was certain approximate way it was applied. And then a very seminal result was invented in 1987, and where this drawback, that discontinuous control which is applied to the system, that is overcome, this drawback, and a seminal result is obtained, which is created an impact on the sliding mode literature. The control problem actually is concerned with the controlling the plant output under uncertainties. Control techniques such as sliding mode was developed, that is the purpose, they achieve the robust stabilization. So as I told you, it was originated in Soviet Union, Emelianov and Utkin, that I have told. And then it's to reject unknown disturbance by some discontinuous control action. Now variable structured system, it is a well accepted technique. The practical applications face challenges in terms of high frequency oscillation, vibrations, actuators known as chattering, and some solutions were proposed to reduce the chattering. A seminal contribution was done by Ariel Levin in 1987. The IEEE Control System Society has a dedicated technical committee on variable structured system, and it is responsible to hold a biennial workshop on this topic. So what is the contribution in this paper? I am just, because this introduction is necessary to feel some of the ideas of this particular paper. In the classical sliding mode control, there is a double integrator, the perturbed double integrator, a discontinuous control, finite time stabilization, but control is discontinuous. In a higher order, second order sliding, perturbed double integrator, control is continuous, finite time stabilization, and there is no chattering. So that is the contribution. Now discontinuous control, so to implement this control, the state information is needed. In a generic mechanical system, you have the position and the velocity. So velocity has to be estimated in finite time. So due to that, a second order observer is also proposed. This is the structure for that observer, and the observer error, it decreases to 0 in finite time, and it exactly estimates the states of a second order system. Now the contribution, what is the main contribution of this paper, which was presented in this IEEE transactions in 2016, that observer based, if a second order sliding mode control is proposed, then mathematically it is incorrect. This is a wrong notion, which was propagated to the community, and it was not understood first. And it is the first time in this paper it was pointed out, and it was shown by mathematics, that if a second order control, sliding mode control, is implemented through a second order observer, then it breaks down. Mathematically, it is not justified. One has to resort to a higher order observer. That is the contribution. The details, mathematics, presentations, proof, everything is given in that paper. So this is the third order observer, which is proposed for a second order generic mechanical system. So this is the control. Control now becomes continuous control. The above control retains the entire property of the higher order sliding mode control. So this is the second order control based on second order observer, and this is the second order sliding mode control based on higher order observer. So it is in this place, the second order sliding mode is not enforced due to the discontinuity in this equation, which is taken care using a third order observer for a second order plant. So this is the main contribution of this paper, and that's why it has got huge attention by the readers of this community. And this technique is implemented to an emulated system which has a drive disk and the load disk. The load disk behaves in the same way as it is behaved by the drive disk. So this particular idea, and the position can be measured by an encoder, but velocity cannot be measured. So this velocity is estimated by a third order observer, and then this is implemented, and then it has been shown that this results much better than a result obtained by a second order observer. So this is the control input, and other is the error in the estimation by second order observer and a third order observer. So this is all about this paper. Thank you very much.
Thank you, Professor Bandyopadhyay. Now I'd like to invite Dr. Anand Mishra from the Department of Computer Science to present his work.
Good evening, everyone. So this is a work which is a decade long, and I did during my PhD. So it is, I think, second or third paper during my PhD. So in this talk, I will be really talking about this work, and also try to give a glimpse of how fast the AI methods or AI techniques evolve, and how fast the things becomes outdated. All right, so so the problem here is simple. So when we take photographs in the outdoor scenes, we often see images which contain text, and we are interested to recognize this text, right? So like what is written in the image. And obviously this has many applications, starting from mobile applications, multimedia indexing. It can help visually impaired people, or maybe also help in driverless cars. Back then in 2012, this was a challenging problem. Today in 2023, it is not, right? But in 2012, there was one of the challenges, there was not enough training data which can be used to train machine learning models for this particular task. There were not enough training data, not even training data. We do not have enough large-scale evaluation sets to evaluate the progress. People were there were focused. There is something called optical character recognition, which has a long history in computer vision and has been highly successful. But those techniques were not really good for this particular type of problem because of various things. Because when you take pictures in outdoor environment, there can be illumination, there can be noise, occlusion, and everything. So, and also, this problem was not really looked from the computer vision angle, where you are interested to detect these characters as objects, and also use the language priors. So our first contribution was coming with, as I said, the data sets were not, the large enough data sets were not there. So our first contribution was this particular data set, which is IIIT 5K data set. It is back then a largest data set, which contains 5,000 images. It has large variations, and we have provided the manual annotations for this. And this data set is publicly available. Our second contribution comes in terms of a model design, which uses the techniques, combining computer vision techniques and language processing techniques. So which is more like using language priors. So back then again, there were no large language models. So we used to use statistical language priors. This work was that has used the language priors to improve the performance. So it's more like what we do is, given a word image, detect characters at various scale and form a graph. And now this graph is like a graph. We impose the language priors in this graph and formulate the problem as an optimization problem, where minimizing this particular function gives you the labeling of this graph, and this labeling corresponds to the recognized text. So this is where we integrated the language and the character detection and recognition scores in a single unified model. So as I was saying, like how fast the world moves, when we did this work in 2012, we achieved around 74% in our work. And back then, that was the SOTA, but soon there were a lot of works, and every year there is a paper in CVPR and IEEE PAMI or NeurIPS, and which has resulted in significant improvement in this particular task. So this particular task, at least for English, now the performance are nearly 99%, right? So on this data set, of course, but yeah, means in general also there are now apps and all. So what is the impact of this work? This work was, like, as I said, like this data set has been heavily used. It has been used by the various reputed groups across the globe. It has resulted in publications in the top tier venues which have cited this work. And it has touched the syntax recognition area, generative AI also in recent years, like for generating scene text. There are some robotics conferences also which are interested in reading text in the images, and now visual question answering and such things. So to summarize, this is like what we did is introduced our largest data set for the problem, which has been useful to the community and which has helped in a tiny way improving this area of syntax recognition. We have integrated the low-level detection and higher-level language priors in a unified framework, which has resulted in good performance. So, and then taking forward these ideas, what we are currently working in our group is one of the problems which we are working is improving the scene text recognition for Indian languages. And soon enough, I think we are working in the problem with this Bhasani, which is a National Language Translation Mission. So we will be having, we have some models already, and we are working towards improving it. And soon we will have open source codes and deployable models for 13 Indian languages. So we will have performance nearly equal to English in 13 Indian languages very soon. And this is the paper which can be downloaded, and that's all. Thank you.
Thank you very much, Dr. Mishra. Now I'd like to invite Dr. Raviraj Vankaila from the Department of Bioscience and Bioengineering to present his work.
Good evening, everyone. So this particular work I've done during my postdoc at National Tsinghua University in Taiwan, and this was published in Advanced Materials in the year 2014. So this particular work is mostly on the development of multi-branched gold nanoakinase-like structures, which is useful for the infrared light activated photodynamic and photothermal therapy, especially in the second biological window. So first I would like to introduce a little bit on photodynamic therapy. Photodynamic therapy is a classical modality in which it is used to treat cancer. So basically it needs a photosensitizing molecule, and it needs a light so that the photosensitizing molecule gets activated, and it can produce a lot of reactive oxygen species which can actually damage the tumor tissue. In addition to the photodynamic therapy, there is also another component called photothermal therapy, where these molecules can produce heat and it can kill the tumor. But the drawback of the classical photodynamic therapy is that most of the photosensitizing molecules are activated only using UV light, or at max it is only, the red light. So there is a great need to develop novel photosensitizing molecules which can be activated using infrared light. And why infrared light is advantageous? Because infrared light falls under the biological window, and it can often gives you reduced scattering, high tissue transparency, reduced absorption from biological molecules such as melanin, hemoglobin, and oxyhemoglobin, and it can also facilitate deeper tissue penetration. So that means you can also be able to tackle deeply seated tumors. And in terms of fluorescence, optical property, it can give you a minimal autofluorescence and an improved signal to background noise ratio. So so it is highly desirable to develop nanomaterials which can be activatable using NAR1 and NAR2 biological windows, especially to tackle the deeply seated tumors. So in this particular work, we have come up with an interesting nanostructure which is called as gold nanoakinase. As you can see, the structure looks like a sea urchin, and it has a multiple nanorods which has been protruded from agglomerates of a nanoparticle. And this particular nanostructure has been formed with the help of a novel double chain CTAP surfactant, in which the structure is represented here. I will not get into the growth mechanism. The important properties of these particular nanoakinase is that they can absorb light very efficiently in the first and second biological window. And the light absorbing capability, or the molar extinction coefficient of these nanomaterials, are in the order of 10 to the power of 12. And they can also sensitize the formation of singlet oxygen in the first and second biological window as well. So you can see the characterization, you can see the SEM and the TEM image of the gold nanoakinase, and you can also look at the broad absorption of these gold nanoakinase in the entire biological spectrum. And then you can also, in panel D, you can see the singlet oxygen generation in the NAR1 and NAR2 photoexcitation. And once we have developed the gold nanoakinase structure and looked at the optical properties, we utilize these nanoparticles for the in vitro cellular experiments. And we feed these gold nanoakinase to the HeLa cell, and then we looked at the phototherapeutic effect to see whether once we radiate with 915 nanometer light, whether we can see any kind of destruction in the cell viability and all. And it is very clear that it produces a lot of ROS in the in vitro as well, and it can also mediate a very high cell death, especially in the in vitro, in HeLa cell. And then we have systemically injected these nanoparticles into the mice, which has a melanoma tumor model, which is, again, this is a proof of concept demonstration. And we systemically injected these nanoparticles into the mice, and then we found that at 915 and 1064 nanometer, which is NAR1 and NAR2, there is no significant photothermal temperature rise, but yet there is a lot of damage to the tumor site. So this damage to the tumor site is mostly originating from the reactive oxygen species, which is being generated by the nanoparticles. And this kind of a tumor destruction is much, much effective when compared to the chemotherapy, conventional chemotherapy effect, or the conventional photothermal therapy alone. So this is the overall working mechanism of the paper. So this nanoakinase can be activated using 808 and 915 nanometer light. But if you use 808 nanometer light, it can only produce photothermal heat. And the downside factor is that you have to use a very high laser power dose in order to get the photothermal heat to kill the cell. But if you use 915 or 1064 nanometer light, which is in the second biological window, you can use a very low laser light so that the ROS can be produced, and it can actually damage the tumor tissue very well. And this work was the first example. It was the first example to show that nanomaterials can actually serve as a singlet oxygen photosensitizers, and that too in the second biological window. So this work was also highlighted as a front cover in Advanced Materials. Thank you so much.
Thank you very much, Dr. Venkayla. That brings us to the end of the scientific research presentations. It was truly wonderful to see the diversity of work that's being done here at IIT Jodhpur. Now, I'd like to introduce you to the third edition of the Moonshot Awards, which are a competitive platform that provide faculty of IIT Jodhpur an opportunity to present innovative and disruptive ideas, which can eventually lead to large-scale solutions to improve health, society, economy, and environment. This edition of the Moonshot Awards, 5 entries were received, which were judged by a jury of senior faculty members, and chaired by our director, Professor Shantanu Chaudhary. The 5 entries that were received were Smart Microbial Applications for Rural Transformation, acronym SMART, by Dr. Neha Jain and Dr. Arani Khan. Second, Karma Band Towards Transforming Individuals by Dr. Palash Das and Dr. Anshman Paul. Thirdly, 3D Printer for Medicated Food by Dr. Sumit Kalra. Fourthly, Lunar Tunnel Boring Machine for Underground Moon Habitat by Dr. Debanjan Roy Guha. And finally, START, STEM plus Art, an Immersive Knowing Reading Experience by Dr. Tunisha Goin and Dr. Romi Banerjee. I would now like to invite Professor Pushpak Bhattacharya to give away the Moonshot Award Prize this year to Dr. Debanjan Roy for his work on Lunar Tunnel Boring Machine for Underground Moon Habitat. I'm really sorry, Debanjan Guha Roy. Dr. Roy will now make a short presentation.
Thank you. This is a short version of the proposal. So this is Lunar Tunnel Boring Machine for Underground Moon Habitat. So humankind is returning to Moon, and we are planning to use Moon as a staging base for deep space missions. India is already on track to launch its Gaganyaan mission, and we have also signed the Artemis Accord recently as the 27th international member. And we have a focus on the extraction and utilization of space resources. So we have started planning and designing moon bases. But whatever base we design, it must give breathable atmosphere, provide protection from extreme temperatures, from solar radiations, and micrometeorite impacts. So why not we move underground? The past remote sensing missions on Moon, they have shown that there are multiple lava tubes running across Moon's surfaces, just below the surface. And they are often exposed through the structures called skylarks. These are lava tubes created in the geological past by the lava motion. And similar tubes we also see in Earth, and we have studied them really well. Based on this remote sensing data and geomechanical study, we have seen that these underground structures are very large, and they're quite stable to house our moon base. But these tubes, they must be connected. And also we need to expand it to other places of Moon. And so we need to create new tunnels. On Earth, we do create tunnels. We use a tunnel boring machine, and we house civil and defense infrastructures. These machines are pretty long, heavy, and it has a rotating cutter head. This cutter head cuts through all strong geological material. But it is a very heavy equipment, particularly the cutter head itself is weighing more than 100 tons. And right now, the cost of sending any equipment to lunar orbit or lunar surface is very expensive. So we cannot send Earth-based TBM to Moon. We have to design a new lunar TBM. Now, this lunar TBM must have 2 aspects. One is it should be able to continuously and automatically map the geological and geotechnical properties of the rock, because there will be less number of human beings. And it should have a novel drilling technology which does not use heavy steel cutters. So the proposed cutter head design will have 2 modes. The first one is the probing mode, where we have the embedded GPR, the ground penetrating radar, which will scan and map the rock surface that is going to cut. Based on the structure and the strength of the rock, we'll go to the second mode, which is the drilling mode. Here we are going to have gyrotron powered drilling platform which will directly melt and vaporize the rock. And the strength of this operation will depend on the property measured by the GPR. The transformation from probing mode to drilling mode would happen through a novel technology where the sensitive GPR would be tucked in safely before the high temperature drilling operation begins. Now, the major science and technology challenges that we have and that we are facing is first is the direct energy drilling technology. Recently, it has been shown experimentally in lab that this is absolutely possible to melt rock, but it has been done in a very small scale. And we can melt rock between 1600 to 300 degree temperature using millimeter wave wavelengths. But we can increase the size of the borehole, but that will also increase the required energy, which brings us to the second problem, the energy supply. Now, this type of tunneling would really require a very high volume of energy, which is not possible using the current state of technologies. So the proposal is that we can actually directly beam energy to the moon surface through a satellite on the lunar orbit. This has been experimented with, and to some extent it has been successful through DARPA technologies. The last one is the loose rocks. The lunar regolith and fractured rock can fly away if you disturb them because of the reduced gravity. So we are proposing to use a claw and spine-based robotic hands that can grip those rocks, and that will save the operator, the machine, as well as the infrastructure on the lunar orbit from those flying rocks. So these are only a few problems I have highlighted here. There are multiple other problems which we need to solve before we plan for such things. So hopefully within 50 years, if we can solve such things, we can use the lunar tunnel boring not only on moon, but also in other rocky planets. Thank you.
Thank you very much, Dr. Roy. Now I request our director, Professor Shantanu Chaudhary, to address the gathering.
Good evening. See, this part of a celebration of Foundation Day, what we said is celebrating the scientific achievements of our faculty and looking into some of the new areas that we love to explore and know more about. In fact, what we have presented and we have seen about 15 presentations, which actually showed the faculty's achievements and the areas that which they have worked, the diversity of the area, the quality of the area, quality of the work, and that is something critical for a new IIT to grow. Because that's a core, what I said in the morning also, intellectual capital of an IIT. And today we have actually made that capital more known to a wider audience, and the capital which is built over 15 years in this institute. Following this, what we have is two very distinguished speakers to talk about their own research. Not only the research, one part of his research, other part is more of technology development. I think in an IIT being an engineering institute, it's not just pure research, but we need to also look at translatable technologies. Technologies which really can lead to things which work, which delivers, not just papers. So we have Director Ada and my old friend Mr. Yadav, who was the director of NAL while I was in Siri, and we worked together in a number of activities. We have here as the guest speaker, and he has worked substantially in aircrafts, in actually all LCA developments, and he's actually a doer. If you ask me, he knows how to do things, how to make things work. And so it would be a unique experience for all of us. Even I know quite a few faculty are interested in drones, and they're working on drones and different kinds of omni-mobility systems, because that's also part of our agenda of IIT Jodhpur Defense, that is IIT DRDO Academia Startup Center that we have here. One of the verticals of that center is omni-mobility systems, which also includes obviously the airborne vehicles, in fact, water to air, land to air, and land and air, those combinations. And that's a very core research we intend to engage in coming years. I think Yadav's lecture actually will open up various new avenues and possibilities, and also can open up the channel of our collaboration, because you're working with DRDO in this space already. And the other speaker is Professor Pushpak Bhattacharya. In fact, I know him for years. How many years? More than 40 years. Okay, and he's I think, most well-known scientist in the area of natural language processing in the country today. And when we talk about AI, and we talk about interfaces between systems and man, then NLP is fundamental. In fact, what Anand was also talking about, the Bhashini project, which is a major initiative of the government of India to actually build systems which can breach the language barriers. Pushpak is part of it. Pushpak has actually worked on that over many years, and we have seen demonstration of the system. I have also tested that system, which really works and can do a translation of what I say in English to in Hindi in a spoken word. So we have two very distinguished speakers to actually, as finale of this celebration of science, as part of our 16th Foundation Day, that is celebration of completion of 15 years of IIT Jodhpur. So we're looking forward to this, and in fact today is also, we had in the morning Secretary Meity, he talked about how the digitalization and in the country is impacting the world, and it's almost a global leader in terms of digital processes that we have implemented when we are in the place. And it was also promised, I think this is something which is very, very important, he promised to create a position of chair professor, Meity chair professor in AI at IIT Jodhpur, and also support for a set of projects for intelligent Internet of Things, which is of the order of 30 crores, and a support for perception and cognitive engineering program, for which we had a workshop a few days back. So therefore, I think this Foundation Day should also be a very important occasion for us to launch into a mission for very high quality research and innovation. And in fact, that's the core objective of today's this celebration of science being organized. And this is not just for faculty, for the students who are all around, they are equal partner in this initiative, in the mission mode initiative to make IIT Jodhpur really a front-ranking institute in terms of inventions and innovations. All the ingredients are now in place. It's a question of delivering and working towards a very well-defined goal. I think today's activity would inspire many of us and many of the students to move forward in a much stronger way in the direction that we plan to move forward. Thank you.
Thank you very much, Professor Chaudhary, for setting the stage for the next section of our program. With that, I'd like to invite our chief guest for the evening, Dr. Jitendra Jadhav, the Director of the Aeronautical Development Agency and Program Director, Combat Aircraft, Bengaluru. Dr. Jitendra Jadhav's contributions to defense research in India cannot be overstated. He steered the weaponization of Tejas as a lethal platform by integrating close combat missiles, laser-guided bombs, BVR, laser designing pod, etc. He developed several key and seminal technologies in this direction. He has more than 33 years of experience in design and development of fighter and civil transport aircrafts, flying trainers, and its associated electronics and control systems. Before taking over as director of the ADA, Dr. Jadhav had served as director CSIR National Aerospace Laboratories, Bengaluru. Sir, it is a tremendous pleasure and honor to have you with us. Dr. Jadhav will be speaking to us today on scientific excellence in aerospace engineering and Indian science. Sir, the floor is yours.
Sorry. So, Dr. Shantanu Chaudhary, Professor Vadera, Professor Bhattacharya. Actually, I've seen from last 2 hours the diversity of work done by all the faculty members here, and certainly, as Shantanu told, that is the wave towards the success and taking institute to the industry collaboration. Because the major thing what we are looking for is the collaboration with the institutes, with the deliverables, which we are having a niche area problems, like lot of we can discuss. But what I found is your material group and all is very strong, and I think we can work around certain things. But over the presentation, we will come to know what best can be done. I have taken this presentation not for faculty members, but for the students also. So bear with me, little bit fundamentals are also included into the presentation. And then we'll taking it towards the technology and digital world and AI and all that stuff. So the first thing is, there is always confusion. What is aeronautics? What is astronautics? What is aerospace? So this is my definition. Aeronautics is the vehicles that stay within the Earth atmosphere, that is aircrafts. Astronautics is the vehicles travel beyond Earth's atmosphere, that is a simple definition. And aerospace applies the fascinating science behind the forces of nature and physical properties of aircraft, rockets, and spacecraft. So this is the third one, which this is my definition. So what we found is, for the student here, we have an aircraft which floats because there are 4 forces acting. One is lift, one is weight, another is thrust, and the drag. So the body gives a drag, and that gets compensated by the engine. And all this low pressure which is developed at the top of the surface because of the high velocity winds, and the high pressure develops at the bottom surface of the wing, lifts the body. But to do that, it's not sufficient. So there are 4 axes. Like one axis I am seeing as a yaw axis, where the rudder authority takes care of the y axis. And there is a pitch axis, where the elevator takes care of the pitch axis. And there is a roll axis, where the ailerons, which are the surfaces at the tip of the wing, takes care. So this is the fundamental aircraft science, where it floats as well as it moves, as well as it controls. So what are the types of the aircrafts? There are fighter aircrafts which are light combat. What does it mean? Light combat means they carry certain weapons like 4 ton, 5 ton, and why light combat is, they got a lot of agility to drop that weapon. So they may work for a dog fight, which is a close combat and all that. There is a medium combat and advanced medium combat, where the aircrafts are highly weaponized, like 12 ton, 25 ton class aircrafts, where their agility reduces, because you have seen, to make the aircraft agile, that controls has to be very powerful, and moment weight increases, getting such a controls agility is a difficult task because you need a high power actuators, you need a more power to drive them, you need a more hydraulics to drive them. So there are advanced medium combat goes for a lower agility. Light combat goes for the higher agility. And there are unmanned combat, which is the new thing. There are certain type of civil aircrafts which are commuter and regional transport. That means they go for 500 nautical miles or 400 nautical miles, and they are more efficient from the fuel point of view, where airlines looks for it. Then there are narrow body and wide body jets, which we travel usually A319 and Boeing 747. There are business jets, there are air taxis, and the research is going on all electric. But to all do this, there are trainers required, because how to get pilots? So trainer is one of the important aircrafts where we call it a jet trainers, which will train the pilot for the first bullet, that is fighter aircrafts. And there are flying trainers which will train the pilot for the civil aircraft. So this is the whole gambit of the aircrafts which is required. Okay, and right side, if you see, we have a Tejas, which is a fighter aircraft, which is our own aircraft, indigenously built. Bottom of that is the Saras, which is also our own aircraft, which is indigenously built. It's a 19-seater aircraft, but it's under evaluation. And bottom one is the Hansa next generation. It's a flying trainer for the civil aircraft. That is also indigenously built and type certified. So let's move on to fighter aircraft. So fighter aircraft story is, I just taken how fighter aircraft has been evolved. So it started in 1914 in the World War I. If you see that aircrafts, they have only one gun, okay? And they are all piston engines, so that engine doesn't have much speeds, they cannot maneuver, they have very low operating time. I can show you one video. So if you see, only gun shells are getting fired in this. There are no bombs, there is nothing. The whole thing has managed with the guns in the World War I. And the piston engines went from 80 HP to the 130 HP, but only gun. What gun will damage, you can understand. Then in World War II, it has come like monocoque constructions, like the complete airframe has come, but still piston engines, but the power has increased from 1000 to 1400 HP. Laminar flow thing has come, and apart from gun, bombs has come. So if you see one of the video, it is dropping the bombs. Okay, so the gun and the bomb has come, and as well as the laminar wing flow has come. So this is how the World War II has been done. So there was no generation that time, because till World War II, we cannot call generation of the fighter aircraft. But then first generation of the fighter aircraft with the jet engines has been started. But if you see, the first jet engines aircraft, few are from Americans and few are from European. And nowhere Russia was there, neither India was there, nobody. But if you see the cockpit there, it was a steam gauge cockpit instrumentation. The complete cockpit is steam gauged. Okay, and very limited operational lifespan of this particular things used to happen, because the total steam and all, what will be the operational life. So then, if you see, these aircrafts used to go for a dogfight. I will just show the dogfight, because both will go behind each other, and then they fire the missiles. Slightly video is not good, but you can imagine, see, we are firing both the aircrafts are chasing each other, and then they will fire the missiles and engage on to that. Then the second generation has come, where the jet engines has been improved, and they went for supersonic speeds. But if you see the wing was monocomb construction. It has become a swept wing and delta wing. So there also India was not there. All is Russia has come, and then still there are Europeans and Americans. So then The second generation to third generation, there was not much change, but the cockpit, if you see, it has come like an analog cockpit. So analog avionics has taken place in second generation, third generation, and more or less the aircraft has increased their control surfaces, power, viewer, all that. So that is in 1970. So 70 to mid 90s, this particular technologies has come up. So we had an aircraft called light combat aircraft, which is a fourth generation aircraft we are talking. And there are a lot of technologies got evolved. There is a quantum jump from third generation to the fourth generation. If you see, there is a fly-by-wire control system. I will explain it, what is fly-by-wire control system. There is a camber wing has come. High maneuverability has come to the aircraft. The glass cockpit we will discuss, high agility and use of composites. So this is called the thing, and we should be proudly stating that India is in that elite club today with LCA there. So if you see the fighter aircraft scenario, now we'll start fighter aircraft scenario because this was of the history. So we have a HF-24 Marut, which was a second generation aircraft, but it didn't pick up, okay, in 1967 because we didn't have technology. Why I'm bringing this important discussion is because if we had a technology, we would have sustained with that aircraft. We didn't sustain. It just died on its own. Then 1990, government decided that we should have fighter aircraft, and 2001, the fourth generation fighter aircraft LCA Tejas, we'll discuss that, has come. Then the variant has come because Tejas needs a trainer, so jet trainer has come of LCA, and the LCA Navy has come. So this is the scenarios where the aircraft has been developed for the fighter aircraft programs. Now coming to the technologies. So if you see the left side, the cockpit is totally glass cockpit. What cockpits we have seen? We have seen a complete steam cockpit, we have seen a dial cockpit, and now we are seeing a glass cockpit. So the technology has come from the steam to the glass. And why it got is glass cockpit? It is very, very easily readable, easily manageable, easily controllable cockpit. That is the cockpit which I am showing for the LCA. Apart from this, we have seen the structures. The structures came with plate type structure, then swept wing. But in the LCA, we have used a composite airframe. So today, LCA is one of the aircraft where 45% by weight and 89% or 86% by area, the whole composite technology has been used. And then the agility of that controls which we discussed, pitch, roll, yaw, has been done by fly-by-wire control system. So what is fly-by-wire control system? So basically what happens is, when the pilot is having a stick in hand, we call it as pilot stick, and he has got a throttle for operating the engine to eliminate the drag or to countersunk the drag. So when he puts a stick, usually all these generations before that, there is a mechanical linkage from the stick to the control surfaces, which we have seen, aileron, elevator and rudder. But fly-by-wire, there is the stick inputs will go by an electrical signal, and that whole thing will get controlled by the digital computer. So these three key technologies, this aircraft why sustaining is, these three important technologies I am showing, living engine, is developed by India. And that is why this aircraft has taken to the sustenance. So the glass cockpit and the avionics was totally developed in India. Composite was developed by National Aerospace Laboratory. Fly-by-wire control system laws was developed by National Aerospace Laboratories, and all the hardware which I am showing was developed by Bharat Electronics. So these are the technologies which has gone into the LCA for making it more sustainable aircraft. So I will just, we call multi-role. What is multi-role? So I will just show you. That is the LCA. It is just dropping the chaff and flare. These drops of chaff flare is basically taking enemy radar out. This is the air-to-ground sortie where we have destroyed the LGB. But Aircraft didn't change. Aircraft has immediately taken and locked to the air-to-air target. So that is called multi-role.
R-73 air-to-air missile on a flare. The flare has been dropped by a MiG-21 Type 96 aircraft flown by Squadron Leader Bhatla. The flare is simulating an enemy fighter.
And the missile has been dropped. So this is called, I don't know whether this video will work, but let us try. Yeah. We will show you the classic technology. The back side is the LCA and this is the tanker. So there is a requirement that you should do refueling in air. Okay. So this is the tanker which is at the front and the LCA is the back. Tanker has put down that whatever our in petrol bunk or something we go, we just skip that mannequin into the our bunk. So that here done. Now the pilot's skill is to connect to that probe and then the fueling is started. From this fuel has started coming and after fueling start he gets an indication and then he detach from the probe. So these are all possible because of the fly-by-wire control. It is not possible by any normal control because pilot cannot do all these things. So this is how it has gone back. So a lot of artificial intelligence also has been put and this is the beauty of this aircraft, which is this. Then we have a naval variant which is very tricky from the technology point of view. I will just tell you how it is possible. See, naval variant, if you see right side, there is a ship, naval ship, and its deck run is hardly 200 meter. And the landing is only 90 meter. 90 meter I have to stop, and 200 meter it should take off. So this is totally very impossible without the artificial intelligence and autopilot into the loop. So we have put an autopilot into this, and this is the way aircraft is taking off. I will show you the fantastic video. This is the this is a Vikrant, which is on 6th February 23. We did a landing. So before starting the video, I just wanted to tell you, these are 3 ropes onto the ship. 1, 2, 3. 3 ropes. We call it as arrestor landing system. Aircraft which is here is coming. There is an arrestor landing hook onto that, and then it takes it, one of the hook, and stops. And while taking off it is, so we'll show you the video, very fantastic video. See, it has taken one of the wire. If he miss the wire, he will go to sea. If he miss the wire, he will go to sea. And immediately it takes off into the 200 meter. So these are the technologies which has been developed in the LCA program. So just going to the status, we are going from Mark 1 to Mark 2, where Mark 1 was having 3.5 ton weapons. Now it will be 6.5 ton weapon. And we will go for a lot of standoff weapons. Why standoff weapons is, in today, it is very difficult to fight the war by entering into the enemy territory. We have to fight the war across our border only. So standoff weapon means their range will be about 200 kilometers, 300 kilometers. So they can go up to Multan, they can go up to Balochistan, or here they can go up to Chengdu. All that thing is there. So that is how it is planned, this Mark II. Now what I come to the IIT Jodhpur for it is, we have a lot of problems of when aircraft lands up, we have to quickly give a turnaround time to them. That we call it as turnaround TRS. Okay. For that TRS, there is a lot of integrated vehicle health management system has to put it in Mark II. And that integrated health management system, I think you can very well take up, because hardware part of that we will do, because we will not penalize, and because this aircraft hardware needs a lot of qualification. However, algorithms in that I will just give you one thing. We have about more than 700 sensors we are planning to put it onto this Mark II. And they will be at the high bearing structural joints, as well as electrical cables, powers, all that thing. All this data has to be taken. Then what onboard has to be done is only spectral data to be recorded. Means there is an anomaly in that data only recorded, okay? Not to do any onboard computation. Then when we get down, we will give that whatever anomaly spectral data to the computer, which is having your IP or your prediction or diagnostics, prognostics and diagnostic algorithms, where they will run that data within a short time. Because they are all algorithms are sitting onto the ground, and then they have taken anomaly data and they have run. And there is a lot of inputs to it, like F-MICA, then fatigue analysis, structural analysis and all that. And based on that, you will allow groundman to clear the aircraft or tell him that this is the flaw, you have to stop the aircraft. So that is what is the new system which we are planning to put it into Mark II. I think we can discuss in more details and then see how best the algorithms can be developed at IIT Jodhpur, I feel. Because I have seen a lot of work done, so that can be taken up. Now coming to the AMCA. So from Mark II, we will be going to the AMCA, that is Advanced Medium Combat Aircraft. There are only 4 aircrafts in the world. That is F-22, though they call it as AMCA, but it's half AMCA. Su-27 from Russia, J-20 from China, and F-35 from the America. So we will be one of the elite club, but this is under development. Now here, a lot of technologies are involved. As Dr. Vadera has told, it's a stealth aircraft. Stealth aircraft means its RCS is very, very low, and it cannot get captured into the enemy's radar. But now enemies, we started stealth material development for X-band. Enemies started reducing the band of their radar to 1 gigahertz. So developing 1 gigahertz to 13 gigahertz or 12 gigahertz stealth material is a challenge. Okay, and everybody is asking that that it should be total band. So that sort of challenges are there. So first bullet is all aspect stealth with integral weapons. Lot of development has been done by DLJ onto that, but there are still a lot of things yet to be done. So I think your material group, which we are talking, and Dr. Vadera is here, I think we can think of some more materials which are not developed, which needs like air intake and all that materials which we need. Now coming to the full sensor fusion. Just now somebody was telling that we are fusing the MRI images, the ultrasound images, then we are fusing CT scan, all that thing. So that's one thing. What we need is, we have very powerful sensors onto the aircraft. And if you see the cockpit at right side, it's a totally different cockpit. You have seen LCA cockpit, there are 4 or 5 displays, but here only one single TV screen. Okay, so the whole sensor information in a fused format, and what is the best sensor to be taken or the fused information will be coming to the pilot for the pilot workload reduction. So this is what one of the algorithms which we are looking for in AMCA, where the sensor fusion and the data fusion of the sensors. See, we have a infrared search tracker sensor, we have a radar, we have a MWS, that is missile warning receivers, we have a EW, that is electronic warfare systems. So all this data needs to be fused, and then we have to project a correct data for pilot to take a decision. So that is what it is. And also the CNI avionics technologies also is one of the technologies which will be coming to this aircraft. This aircraft is not yet sanctioned, but it is advanced way of sanctioning. But when it comes, it is a 10 years we have to give an aircraft to the Air Force. So that is the idea. So a lot of technologies are involved. Few technologies are already in some TRL level. At least stealth materials is at good TRL level. But other technologies, and here The IVHM, what I was talking, it will be on board. It will not be off. In Mark II, it is off-board IVHM, Integrated Vehicle Health Management. In this, it will be on board. That means on board itself, it will be calculated, and before landing, everything is ready. So there won't be any TRS time, turnaround, servicing time will not be there. So AMCA is a 5th generation twin engine, because there is that all aircrafts what we have seen today is a single engine. This is a twin engine aircraft, and it has got stealth shaping and all that thing has been done. But internal weapon bay, divertless, supersonic, serpentine duct, radar absorbing material are the critical technology. We are taking AMCA variant for the naval. So we call it as twin engine deck based fighter, that is at the right side, where the same AMCA variant but not stealth, but all the technologies of AMCA will be utilized, and this will be a replacement to 29K, MiG-29K. That is also 26-ton class, and this project is also yet to come. But these two will have a common technologies apart from the specific to Navy. With this, what is going to happen is, today about 500 aircrafts in Indian Air Force, there is a plan to replace all 500 or 550 aircraft, but plus addition 200 aircrafts with the indigenous. So we have LCA Mark I, which is already in the production, Mark II, which we discussed, then AMCA and TEDBEF. So with this aircraft, there won't be any foreign aircraft in the Indian Air Force. So that is what the vision is being driven. So a lot of technological collaborations can happen. So this is how we have evolved, generation 1, 2, 3, 4, and we are proud to say that we have at 405 at LCA. Now coming to civil aircrafts. So civil aircrafts, as I was telling you, there is a training need of the pilot, and today 1,000 pilots are required per year and 700 pilots goes outside. So we have come up with a fantastic aircraft called Hansa NG, which is the very latest technologies. Like it has got also glass cockpit, it's a different material, just in prepreg, electronically scanned, long endurance and all. And this aircraft is going for the, if you see the cockpit, it's a very advanced cockpit where the complete glass cockpit and all. And this is being type certified recently, and this will go to the production shortly. Now coming to the commuter aircraft, we have revived the Saras, which is flying now, and then we went for Saras Mark II. So this is the Saras flying. It has gone with the fatal accident because aircraft of civil aircraft is very difficult to develop and make it more safe. So during one of the flight tests, it went for an accident in 2009. Then 2018, we revived. And now we got a Mark II, which is a totally different. So Mark II will be a turboprop engine, which is showing, and it is on the wing. Earlier was at the stub wing. And it has got lot of technologies. The technologies is the whole thing, aircraft, if you see this simulator, you will not feel it is not on ground, but after some time you will feel it is on ground. Okay, so whole aircraft will be evaluated in simulator before it takes up for flying, and it's a very high fidelity simulator has been developed. But if you see now, it is on ground. But if you see earlier, and lot of autopilot, avionics, here also IVHM will play lot of role, and it has lot of technologies for this. So, and the future is, government has already given a clearance for 90-seater aircraft, so that will also come. So, general civil aircraft, 2021 Hansa NG has gone to production. About 2026 Saras Mark II will go, and about 2028 RTA will go to this thing. So, this whole technologies needs to be commonalized between civil and fighter aircraft. It cannot be separate technologies. Only qualification levels and other things will be different. So that is how it should be driven with the, and we have a lot of challenges here with academic institutes to be done. First of all, what I will tell you is, suppose this is a turboprop, and then there is a exhaust. It comes directly to the wing in civil aircraft. So that sort of exhaust management and all needs different type of thermal coatings and all that thing. So a lot of challenges in this. So coming to technologies, which is today's chapter. So what we are looking for technologies. One is low RCS, that is stealth materials, which are at high TRL level, but still we are looking for the technologies. Second one is reduction in pilot load, that is electronic pilot. That's what we were talking about it. What is electronic pilot? Electronic pilot means you have a lot of sensor information coming, and the electronically you are giving to the pilot which information is required only. Unnecessarily you are not cluttering him with the lot of information. That is called I am making simplified, but there are so many things are further coming. Then reduction in maintenance, that is what technology we are talking, that is integrated vehicle health management. Then we have a battlefield surveillance and situational awareness, we will come to that. Then combined vision enhancement, we will show you. Next generation engine, which is slightly difficult in our country, but we can take that as a technology. And more electric systems. See, today what happens is, slowly in civil aircraft, we need to not depend upon the bleed of the engine. What we do is, our air conditioning system in the aircraft takes bleed from the engine, hot air from the engine, then it goes to the heat exchanger, cold air unit, and then it go to the compressor and it becomes a cold, like air condition. So, usme kya hota hai? The total efficiency of engine goes down, because during takeoff and all, we need lot of power to be taken from engine, and that power get compensated to the engine power. So what we are looking for is, do away with this engine bleed and make an electric system where that can give a air conditioning. Okay, it may have a impact onto the generator and all. So that is what we are looking for. And of course, high performance ke liye we are looking for lightweight airframe, special coatings, aerodynamic optimization studies and all. So these are the technologies we are looking. Now this is the AI based, what we are looking for is MUMT. MUMT is basically man-unmanned teaming. So today, suppose these two black aircrafts, one is the black aircraft and these are the small aircrafts, okay. So this black aircraft, which are one, that is a manned aircraft, okay. Just see how artificial intelligence has to be done. So this is a manned aircraft and these are all unmanned aircraft, that is all chota aircrafts are unmanned aircraft. So what we will do is, so manned aircraft will take coordinates of this aircraft, which is a target or which is an attack aircraft coming towards him, and then he is doing a circle here and he will pass it on all data to these unmanned vehicles, okay. And then this unmanned vehicle will go and attack that fellow. Okay, manned fellow will remain at the safe distance. Okay, so that is called manned-unmanned teaming, and it needs lot of different sort of network-centric logics to work. Okay, it's not very simple, because you are sending an unmanned towards that target, and then that unmanned will have some small weapon which will hit the target and come back. So that is called man-unmanned teaming. Right side, if you see, in the combined vision, which is what I was talking, one of the part of electronic pilot. So what we do is, we have a night flying or bad weather flying and all that thing. We don't have technology today. We have sensors, but we don't know the technology. So there is a synthetic vision to be given to the pilot, and then he can land or he can keep going into the bad weather. So that sort of artificial intelligence we are looking for. Bottom, if you see the bad weather, it will be very bad, and this is the cleared weather which has taken from the bad weather and the sensors and given a total display of outside to the pilot. That is bottom. So that sort of AI-based technologies we are looking for all these platforms which are coming from AMCA, TEDBF and onwards. Now coming to manufacturing technologies, because that is most important for us, because we are struggling to manufacture aircrafts at the same rate which is required. So what we are looking for? We are looking for a part count reduction and smart structure with fewer joints. So this is what technology which is must to put it into this aircraft, because joints should be less and this. Also improved surface finish, because if you have to make a AMCA type aircraft and sell, the surface finish should be very good. So that is how it is required. Then there is a lean manufacturing, increase order, all that particular technologies has to come into these aircrafts to get going. So when I was talking to Dr. Arun, you are having a course for design and manufacturing. Probably we can work into that and see what best can be done. And then last but least is digital tools. So today, the whole aircraft design is a digital twin and digital tools. So what we do is, people may be feeling these are all software, but it's not softwares, okay. One is requirement management we take, that is a different, we call it as PLM framework. So PLM framework is Project Lifecycle Management Framework. In that all requirements are captured. Then your CFD, which does, let us say, some people here know CFD, they know Paras code, CFD++ and all. They will take aerodynamic optimization. That will come into the knowledge capture and reuse. Then from there, a model-based system engineering we are doing. So take all that particular thing and start doing a model-based system engineering. After model-based system engineering, we do a simulation that aircraft is meeting just a bare minimum performance. Then we go for a FEM, that is finite element modeling with Nastran, ANSYS and all. And that model again we take for virtual reality. And in that virtual reality, pilot really sits onto aircraft. Aircraft has not been made, but the pilot is there. And the whole design will be verified there in virtual reality. Okay, and then the complete manufacturing, digital manufacturing and all that thing will start. So this is what the thing we are using. Ki majority of problems are solved at virtual reality way. That is pilot anthropology, pilot performance, aircraft performance, then all maintainability. Everything is solved at virtual reality. So there will be always circle inside. And then we go for drawing release, CATIA, CAM, digital manufacturing and all that. So this is the new digital twin. We are using it for our program. And these are the national facilities, which is our asset. So we have 1.2 meter wind tunnel, which will be slowly go to 2.5 meter wind tunnel. We have 0.6 meter wind tunnel. We have fatigue test, acoustics test, sled test, and what and all. So wish you all very happy Foundation Day and thank you very much. Question any? No problem. Questions, one or two I can take if you permit.
Sir, these planes, for these planes, you are talking about material, but Russia and USA, they have built plasma-based systems and are flowing plasma onto the surface of the plane. So, and that is restricting the signal, microwave signals to pass through. Are we working in that direction?
Actually, for the stealth aircraft, there are three things we are working on. One is by shaping itself. Second one is we are completely simulating the aircraft with all that, whatever its properties and all. And there are two materials, as you rightly pointed out. One is radar absorbent structures. That means the whole material itself will come as a full structure like a mechanical alloy, like aluminum and all. So that is required for very particular place like air intake and all, because they are all open to the enemy radar. So there we are using radar absorbent structures. So there a lot of research has been done, what type of material to be used. Basically they are all ferrite molecules and all that. However, other places we are not going for radar absorbent structures because the structure itself is having a lot of problems from the strength point of view. Okay, so there we are going for coatings, paint, which is already developed by DLC. Okay, so that is how the whole thing has been managed. But the major thing is by shaping. Not that material, if you start solving this RCS issue, you will be nowhere. First you shape it, model it. In fact, we are making 1:1 model to take readings. And then put a material at appropriate place where the red spots are there and all. So this is how we are going. But Russians are having and Americans are having a different technology. They are basically talking about, as you said, but I think we are going in a different approach. And it looks to be a workable approach, what we are taking. Probably we may land up into little bit weight, but doesn't matter because that is the area we are thinking to go ahead. RAS, RAM, and surface finish and shaping. This is the idea to manage the stealth today.
Sir, in one of your slides, you have told that for high-speed stealth aircraft, you need a very good surface finish of the overall surface. And what I assume that surface is a free-form surface. And my question is that, do you have that technology for getting the high surface finish on this free-form surface? Or you are looking for some advanced techniques to achieve that ultra-precision finishing on that kind of free-form surface?
Good question. Today, we are getting surface finish not less than 1 mm or 1.2 mm. The technology which we are having of prepreg and composite, we cannot get less than 1.2 mm. Okay. And the metallic surface finish we may get, but these all more or less surfaces are composite. So what we are looking for is, the whole thing needs two type of technology. One is this prepreg laying, which we are doing semi-manually, has to go into the complete automatic. The laying of the prepreg and making that composite part. After that, when there is when it comes out of curing, autoclave, there are now optical guns has come, which makes that optical guns onto that surface to give that finish. Okay, so that sort of technology, but it is not available so easily. What they are doing is, suppose composite has been made from the autoclave, there will be, like our mechanical part, we don't have stress relief and all in composite. Mechanical is having stress relief, aging, weaging and all, but composite we don't have. So what people has come with, they vibrate that particular portion where after inspection by ultrasound waves.
Vibratory policy.
And remove that particular thing and give the surface. So that is how we are looking for.
So some flexible finishing process is there, like magnetorheological finishing and shape adaptive grinding kind of thing. Those finishing process can confirm the local topography of the workpiece surface and can and nano level surface finish can be achieved very confidently. And those I am also working on those ultra precision finishing process. And in my PhD study, I have achieved around less than 5 nanometer surface roughness on a very hard coating like a WCCO coating, using this flexible finishing process like magnetorheological finishing and the shape adaptive grinding.
It's interesting, we can have a dialogue.
Yeah, thank you very much.
Great. We can have more questions during some tea time or something. Thank you very much.
Thank you very much, Dr. Jadhav, for that fascinating insight into the history and challenges of modern defense and civil aircraft development, as well as laying out the significant research opportunities in this direction. Thank you very much, sir. Now I would like to invite our next speaker for the Foundation Day oration. Professor Shantanu Chaudhary so succinctly summed up Professor Pushpak Bhattacharya's achievements by saying he is the most well-known scientist in the area of natural language processing. Professor Bhattacharya is the former director of IIT Patna. He served from 2015 to 2020. Dr. Bhattacharya is currently a professor of computer science engineering at IIT Bombay. He has been associated with the IIT system throughout his education trajectory with a BTech from IIT Kharagpur, an MTech from IIT Kanpur, and a PhD from IIT Bombay. In the area of natural language processing and ML, he has more than 350 research papers covering all its major areas. Professor Bhattacharya is an editor of the Journal of Natural Language Engineering and an editor of AI magazine. His work on computational sarcasm has been covered by national and international media. He is a fellow of the National Academy of Engineers and he was the Abdul Kalam National Fellow 2020. His research excellence has been acknowledged in multiple ways at IIT Bombay, and he holds several significant chair professorships. Sir, it is our absolute pleasure to invite you to deliver the Foundation Day oration.
Okay, good evening to all of you. And it is my absolute pleasure to be part of the Foundation Day celebration at IIT Jodhpur. And I would like to thank Professor Shantanu Chaudhary, Professor Ankur Gupta, and all the organizers of this event. We saw a celebration of science and technology, literally. And the diversity and quality of work is absolutely mind-boggling. Now, being the last speech of today, and also being the Foundation Day, I thought I'll take a bit of liberty and keep the lecture not very heavyweight. I hope that's okay. There is a lot of science, a lot of mathematics, probability, linguistics behind natural language processing, but I don't think we have time to go into those details. But I would also like to demonstrate our work off and on. Now, I would like to tell you the story of natural language processing, the story of how linguistics and machine learning got married, and to extremely interesting effects. So the talk is titled Natural Language Processing, Foundations and Frontiers. Now, before we start, just to set the tone of this lecture, here is a poem I would like to recite to you. And this poem is composed by me. This is called Ode to Scientists and Engineers. Scientists ask why, engineers ask why not. Scientists wonder at what is, engineers wonder what could be. World couldn't do without either. Scientists study, engineers make, and ever the twain shall meet. So we got a proof of this in the last lecture. Okay, the director of EDA beautifully illustrated this very point, how science and implementation, conceptualization and implementation come together to create very impactful, innovative systems. So this is the theme of the talk, and this is the theme of our work also, always. So to reinforce this further, the bread and butter of science and technology is this pipeline: phenomenon, modeling, implementation, analysis, and future outlook. Now, to illustrate this point, I would like to remind you of this phenomenon, namely, for every action in nature, there is an equal and opposite reaction. So this is the phenomenon. And an expression of this phenomenon, the modeling of this phenomenon, is in this equation: m1v1 plus m1v1 plus m2v2 is equal to m1v1 dashed plus m2v2 dashed. So now, this is the conservation of momentum, and this is a restatement of third law of motion. So let's remember this point, that the phenomenon is studied in depth, and a mathematical model is proposed. Many times the mathematical model captures a part of the phenomenon, but that is a way forward. Continuing in the same vein, since in natural language processing, we have to deal with language phenomena, we need to understand what is this object called language. Now, this was very deeply studied and expressed by this seminal work of George Yule, a language scientist, namely linguist, in his seminal book called Study of Language in 1998. So there are 6 properties of human communication embodied in the form of language. The first property is absolutely intriguing, and you will see why this should be in the first position as far as these properties are concerned. This property is called displacement. Now we know that human beings are characterized by their capability for imagination. Okay? And one of the elements of imagination is being able to be present at a time or a place without being actually physically present. Okay? For example, these sentences are valid sentences of human language. I saw him yesterday at the market. I will see him tomorrow in the school. Notice that neither yesterday nor tomorrow, neither at market nor in the school, I need to be physically present, but I can talk about it. Okay, I can communicate this idea to another person. So this is a property of human language. It is proved that animal communication doesn't have this ability of being displaced in time and place and still communicate these ideas. This is proved. Then there are other properties like arbitrariness, productivity, cultural transmission, discreteness, duality. I will not go into those details, except for the third property, which is potentially infinite number of sentences. So this is an amazing introduction of a finite framework being able to produce infinite number of strings. Human language has this ability of producing infinite number of sentences, but they can be captured by a finite set of rules, context-free or context-sensitive. Okay? So this finite framework producing infinite number of objects is a property of human language and is very characteristic of human communication. Then we would like to be in this phenomenology kind of framework and think about what is language phenomena. So there are a number of intricate language phenomena, and we study them all the time, especially in linguistics. So here are some examples. The first example is sandhi, phonetic phonological transformation at morpheme boundaries. For example, guru plus adesh, the sandhi rule is gurvadesh. Okay? So u and a symbol produces this wa sound, and that is the sandhi rule. So this is the order from a teacher. In German, when we form questions from declarative sentences, the verb has to be fronted. The verb comes to the beginning of the sentence. So trinkst du tea means do you drink tea. Notice that in English, we cannot bring the verb as such. We have to introduce an auxiliary verb and bring it to the front. Then there is this notion of incongruity, syntactic and semantic incongruity. And semantic pragmatic incongruity leads to a very interesting language phenomenon called sarcasm. So for example, somebody was invited to a party and nobody attended to this person. So when this person was leaving, the host asks him, how did you enjoy the party? By the time the person is extremely irritated, he answers, oh, I love being ignored. Okay, I love being ignored is a sarcastic sentence. So this is a phenomenon, language phenomenon, and needs to be addressed. Now, there are many corner cases in language. We would call them rare language phenomena. Sarcasm is one of those phenomena. So 11% of the tweets are sarcastic, and out of that, 17% are numerically sarcastic. So if I say, oh, I love my phone, which has 15 minutes of battery backup. Okay, are you really loving it? No, it is a sarcastic sentence. Now, when we talk of language phenomena, we have to also think of modeling it. Now, this has become very easy in today's deep learning world. Modeling is in the form of deep neural network, and it is known that deep neural networks are universal function approximators. So we take a universal function approximator and introduce an appropriate loss function. That also often doesn't need much of thinking or intricacy. The loss function is typically a softmax probability distribution, and it is compared with the target probability distribution through cross entropy. This is almost a universal practice. Okay, deep neural network and softmax based loss function, cross entropy loss function. That is what there is in modeling. However, we can be mindful of the task properties. So for example, here is a network which does hyperbole and metaphor detection together. So I'll talk about it a little more when we discuss the frontiers. We are still at the foundations discussion. So, so modeling is done by deep neural networks and loss function. So we, of course, have had a long line of work in investigation of rare language phenomena. Now, the nature of NLP. Natural language processing is the art, science, and technique of making computers understand and generate language. So we note the two terms, understand and generate. So natural language understanding, NLU, and natural language generation, NLG, both are important. NLG has suddenly assumed a lot of importance because of generative AI, ChatGPT, and so on. But natural language generation is at least 40 years old. Okay. Now, because of very powerful architecture and lots of data, natural language generation has assumed a different kind of importance. Here is a bit of history. Natural language processing is said to have been born in 1940s, and there was a practical need. USA and Russia were in Cold War, and there was a need for translating communication between USA and Russia. That is, English to Russian and Russian to English translations was a practical need. Those were the Cold War days. Then in 1957-70, there was this war between two paradigms, symbolic NLP and symbolic AI also, versus probabilistic data-driven AI. Now, rule and knowledge-based versus data and probability-based. In 1970s, saw the introduction of logic-based NLP, okay, how to capture language phenomena through logic, and Prolog was born as a programming language. 1983-93, we saw more empiricism and a reign of data, probability, noisy channel, graphical model, they came into being. Hidden Markov model was ruling the roost for a long time. Then 2010 onwards, neural models have come with gradient descent, backpropagation, and so on. So this historical perspective is important because there was a beautiful paper by Ken Church which showed that every 20 years, the pendulum oscillates. Okay, so we go back from rationalism to empiricism and empiricism to rationalism. So this is a trend in history if we look at AI. Now, NLP has immense practical utility. The global natural language processing market is worth 15.7 billion in 2022. It is expected to grow to 49.4 billion by 2027. This is caused by data, machine learning, development in systems and architecture. And there are two important paradigm shifting developments, namely word vectors and transformers. We'll look at them a little later. Now, there are two pillars of natural language processing, namely linguistics and probability. There is a coded natural language processing system which does useful job, but they are based on linguistics and probability. Where does linguistics play its role? Before the machine learning model operates and after it has operated. So before the machine learning model operates, we need to prepare data. We need to have annotated data for training the machine learning model. That requires linguistic insight. To give you an example of this, if I take the word golf club, golf is a noun, but it is acting like an adjective here. Okay, no dictionary will mention golf as an adjective. So what should we do? We introduce a new category called adjectival. That means a non-adjective functioning as adjective. So those kind of linguistic insights are needed when we annotate data. And after the machine learning model has operated, we need to understand the output of the machine and also do error analysis. There again, linguistic analysis is needed. So this was quite apparent to us when we were working on machine translation. We have been working on machine translation, which is a very relevant problem for the country for a long time. So we saw that Dravidian languages, whatever you do, the blue score, which is a metric for machine translation, was never very high. So we could trace it to the fact that Dravidian languages are morphologically very complex. Okay? So you create long strings of morphemes to express a thought. So one of my favorite examples is Ghara Samor Chani. Okay, it's a Marathi word, Ghara Samor Chani. All these are joined together. The equivalent Hindi is Ghar ke samne wale ne. So Ghar ke samne wale ne are all separate morphemes, but in Marathi they are all joined together. So this needs to be handled, and that is not understood if we do not have linguistic insight. What is the role of probability? So since NLP is language science and data science, of course, how can you ignore probability? But if we look closely, there are two laws which operate for use of probability in data science. First is law of large numbers. The second is central limit theorem. Okay, so the implication of these two law and theorem is that as the amount of data increases, okay, the confidence in the probability values also goes on increasing. So this is very intuitive, but there are proofs and beautiful theorems and lemma for establishing this. But these linguistic insights and these data insights, they are always in the background for effective natural language processing research. So now what is the main challenge of natural language processing? We deal with language effortlessly, spontaneously, every day. So what is the main challenge when we want to implement this ability on computers? The main challenge is ambiguity. So here is an example. This lady is talking to her dog. The neighbor tells me you are chasing people on a motorcycle. Dog says he is lying. I don't even have a motorcycle. Okay, so what is the issue here? The issue here is incongruity. Who is on the motorcycle? Okay, people or the dog on the motorcycle, and that is happening because of what is called structural ambiguity. So incongruity leads to ambiguity, which again leads to humor. Okay, so this is very characteristic of rare language phenomena. Many times it is incongruity which produces that phenomenon. Now, these are some actual examples. This Vivid Bharati channel is very famous on radio. So I heard this on 29th March. Aaj karyalay band rakha jayega. Okay, and if you change the pause, Aaj karyalay bandar kha jayega. Okay, so this says that if the pause is changed, then the meaning also completely changes. How come we are resilient against this kind of meaning disruption? It is because there are semantic and pragmatic layers operating in our brain which filters out impossibilities. Then if you look at this sentence, 3rd December 22, World Cup, Football World Cup, Korea leave Uruguay in tears. So the meaning is they beat Uruguay in FIFA. Who was in tears? Uruguay, this is a question. Then is Uruguay a place or a team? What does leave mean? Go or cause? Okay? So these ambiguities are rampant in natural language processing, but because of the resilience of syntax, semantics, knowledge, and so on, we are able to filter out impossibilities. Now here is an interesting ambiguity situation which is actual and very typically Indian. There was this WhatsApp conversation between two ladies. Both the ladies were English educated and Bengali native speakers. Lady A wrote to Lady B Yesterday you told me about a shop that sells artificial jewelry. Lady, key naam jano. So BN/BN is an XML like tag. What did you say the name was? Lady B wrote cryptically NYKAA. Because on WhatsApp you cannot really write wrong sentences. That's not very convenient. Lady A is very offended. What do you mean, madam? Is this the way to talk? Lady B is surprised. Kano ki holo? Why, what happened? And Lady A did not reply. She was very angry. What is the problem? I think Bengali native speakers will spot the problem here. Okay. The problem is the following. NYKAA is the name of a fashion industry. They're doing very well in selling jewelry, fashion articles, and so on. And there is a derogatory word in Bengali called Naka. Okay, it means a pretentious person. And this is never a word used in decent communication. So Naika and Naka are homophonous. Both the ladies are English educated. Both of them are native speakers of Bengali. So these four factors sort of colluded to create this ambiguity and breakage of communication. This is an actual communication. I was witness to it. Okay, so this is typical of Indian situation because we do code mixing all the time. Now, linguistics again can be descriptive and prescriptive. It is important to keep this in mind. When we create NLP systems, we cannot ignore language phenomena. Okay, otherwise our system will be narrow in its scope and also limited. So we have to take language phenomena as they are, and we have to find technological solutions for dealing with them. So for example, WhatsApp, SMS, tweets, communication, dialects like Bhojpuri, Silati, Maithili, they are all language phenomena. They have to be brought under the ambit of natural language processing. So technologies have to be created. Prescriptive linguistics is what we learned in our schools. Our teachers told us, don't use double negative. I do not see nobody in the hall is not allowed grammatically, but we know English speakers do use double negative at many places. Okay? So that's a language phenomena, it is real. So natural language processing is done in layers, starting from morphology, which is at the lowermost layer, that deals with words, and goes through semantics, syntax, discourse, co-reference, and so on. The final layer is lots of text together, and you have to make sense of that text, solving many very, very difficult problems. I'll point to some of them towards the end. So this task versus technique matrix is very sacrosanct in natural language processing. On the rows, we see natural language processing tasks, morphology, part-of-speech tagging, chunking. These are foundational NLP tasks. Machine translation, sentiment analysis, these are applications. And on the columns, we see techniques. When we were doing natural language processing long back, 20, 25 years back, we had to sit down and create rules. Okay? So when we translate from English to French, the adjective goes after the noun. So give a rule to give this ability to the computer. Okay? The computer will automatically place the adjective after the noun. Now, then came some data and classical machine learning like support vector machine, expectation maximization, they were used. And now this is the era of deep learning, stable diffusion, generative adversarial network, variational autoencoder. These are very powerful mechanisms, but the caveat is that they need huge amount of data. But when data is available, there is no option other than, should not be using any other option than deep learning. Now, finishing the foundation discussions now, there is this language typology, and it was interesting to see some of these mirrored in what Professor Mitali Mukherjee presented. So there is this, just like there is this established fact that human beings came from some region and then diversified and populated different regions of the world, there is also this established theory that there is something called proto-language. Okay, all languages came from one particular source, and the most important evidence for this is this phonetic similarity. The word three is pronounced as Trayas in Sanskrit, Tres in Latin, God is Deva in Sanskrit, Divas in Latin. So why there is so much of phonetic similarity? There is about 6,000 kilometers between Italy and India, and how come there is this phonetic similarity between the two languages. So the theory is that all languages came from one source. Now, an interesting fact is that this we learned in the school, sentences have the structure of object, subject, verb. Okay, subject. There are these three entities. Now you can have 6 permutations and also a 7th possibility of no order at all. Indeed, there are languages in the world which have these permutations. So subject, object, verb, Hindi is an example of this. Subject, verb, object, SVO, English is an example of this. VSO, Tagalog in Philippines. So the interesting point here is that about 90% of the languages can shift verb around, but has to keep the subject before the object. This is a very interesting fact. Okay, subjects typically come before the object. Ram ne sham ko dekha. So object sham is after subject. And then of course there are other orders also. Sanskrit does not obey any particular order. Sanskrit is no dom, that is no dominant order. And we also know that in India we have these language families, Indo-Aryan in the northern part, Dravidian in the southern part, and Tibeto-Burman in the northeastern part of the country. Also there are 2 languages, Austroasiatic, Khasi and Munda are examples of those families, that family. And for NLP, especially for transfer learning, zero-shot learning, meta-learning and so on, this diagram is important. Punjabi and Gujarati are linguistically similar because they have the same parent. Okay, Punjabi is somewhat distant from Assamese, and Bengali is very, very distant from Tamil. So this is the language tree which tells me that this is the case. And this is very important for creating machine translation systems and also for transfer learning of systems. If I have created a chatbot for Punjabi, I can easily, quite easily, transform it into a chatbot for Gujarati, but not so easily for Tamil. Okay, so this language tree is helpful for that. Just 2 more foundations. This came from speech technology, the noisy channel model, where we probabilistically obtain the output, given an input, from this argmax computation. So choose that E which has the highest probability. And then you can apply Bayes' theorem, use Markov independence assumption to estimate these parameters. The other important development is backpropagation algorithm, the gradient descent algorithm, where the parameters of a deep neural network are learned by this universal rule of eta delta O, and the rule takes different forms for the output layer and the hidden layer. So we have been working on NLP since 2000 in our lab, and we have worked on all areas of natural language processing, including multilinguality and multimodality. Now let's come to some frontiers. So first frontier we see is the word vector. Okay, word vector is an embedded representation of the words. So words are symbolic entities. Now a dog and cat, as far as the character similarity goes, this has 0 similarity. D-O-G-C-A-T, no similarity. Okay. On the other hand, dog and doll has more similarity. 2 characters are common. But semantically, dog and doll are far apart compared to dog and cat. How is that captured? That is captured by word vectors. And we create the word vectors from this kind of feed-forward network, where the hidden layer does dimensionality reduction, and the weights going from the 1-hot representation of the input vector to the hidden layer can give me the word vector. But this has a very strong linguistic foundation. In fact, without this foundation, word vectors would not have been possible. This is the hypothesis of distributional similarity. A word is known by the company it keeps, and words with similar distributional properties have similar meanings. So this is the linguistic foundation of word vector. I would like to call word vectors as a frontier. And frontier 2 is representational learning. So when we use transformer, masked model, large language models, all these are based on representations. So representations are also embeddings. So when we look at these symbols, 1, 2, 3, etc., we do not find any similarity in their grapheme representation. But their distances are more or less depending on where they are on the real line. Okay, so that is the importance of vectorizing symbols and going from symbolic representation to geometric representation. And the purpose of embedding is to be able to enter geometric space and make use of lots of geometric properties. Frontier 3 is transformers. So transformers, we have many very famous examples, BART, XLM, Muril, and so on. So they are again based on two pillars. One is attention, the other is positional embedding. Again, we do not have time to go to their details, but transformers are what they are because of these two powerful ideas of attention and positional encoding. And this is the diagram which has become very famous. This is the decoder stack, the encoder stack, and on the left is the encoder stack, and on the right is the decoder stack. Okay? So this is a recent development, and all large language models are based on transformers. Now, this is the chronology. In 1990, we got the IBM models of alignment. Then came phrase-based machine translation in 2003, encoder-decoder in 2014, which is when Google migrated all its statistical machine translation system to neural machine translation. And now the transformer is the main technology which has been in existence since 2017. So now I go to a small piece of our work in the remaining time, and I'll end with one or two demos. So conversational AI and empathetic computer. So this is an interesting study from Harvard Business Review in 2015. There is a direct link between empathy and commercial success. Businesses are more profitable and productive when they act ethically, treat their staff well, and communicate better with their customers according to the latest Lady Geek Global Empathy Index. So when the interaction is empathetic, it also leads to commercial success. And therefore, chatbots cannot be an exception, okay? Because chatbots also need interaction with human beings. So we need to endow computers with empathy. And in 2015, this Harvard Business Review brought out a list of companies ranked according to their global empathy index. So LinkedIn topped that list. This was quite some time back, about 8 years back. And Google was in 7th position, Nike was in 8th position, and so on. Okay? So empathy is considered important. And we ourselves in our sponsored projects, consultancy projects, we have heard from airlines industry, insurance industry, that now the organizations are competing with respect to their empathy index for their chatbots. Okay? The more empathetic a conversational AI or chatbot, better is the business prospect. So this cannot be ignored. Now, there has been a lot of attempts at automation of this conversation. Instruct GPT is one of the nice examples. ChatGPT, of course, has revolutionized this particular field of conversational AI. And it must respect the pragmatics of the communication. Now, the pragmatics of communication had interesting theoretical underpinnings due to the work of Paul Grice, a famous linguist. There are 4 axioms: quantity, quality, relation, and manner. I'll very quickly mention them. So if the question is, do you know where the IIT Bombay library is? Then if I answer, yes, I do, it is near the maths building, then it satisfies the axiom of quantity. But if I say, yes, I do, and say nothing more, then it violates the axiom of quantity. Quality is being sincere and truthful. If you answer correctly, where is the library of IIT Bombay, then it satisfies axiom of quality. Axiom of relation is that of relevance. If the question is, do you know where IIT Bombay library is, and if the answer is Mumbai is a big city, then it violates the axiom of relation. Axiom of manner is interesting. So look at this question, do you know where the IIT Bombay library is? One of the possibilities of the answer is, yes, I do, it is near the maths building. But if the answer is this, up yonder in the citadel of learning where polynomials are bred and operators are the butter, and where Hardy and Ramanujam permeate the atmosphere, thither we will find the storehouse of what bibliophiles love. So essentially you are saying that the library is near the maths building, but in a very decorated way. one day I was thinking, how should I teach the axiom of manners? So I constructed this example for them. And then I asked ChatGPT what it thought of this answer. Where is the library? And then this is the answer, up yonder in the citadel of learning, etc., etc. Now ChatGPT came back saying, based on the answer given, it seems that the person is using figurative and poetic language to describe the location of the library. So the fact that this language is figurative and poetic, that could be detected by ChatGPT. And also it suggested the answer may not be helpful if the person asking the question simply needs a straightforward answer to the question. So one can see, the advancement in conversational AI. It is possible to be sensitive to metaphor and sarcasm and such phenomena. We also have some work in this direction. So there is this wish list. A conversational AI agent must understand and respond to emotion, decode sarcasm, humor, understand rare language phenomena like metaphor, hyperbole, irony, etc. So on this vein, let me very quickly present to you our recent paper in ACL, which is on hyperbole and metaphor detection, a match made in heaven, multitask framework for hyperbole and metaphor detection. So hyperbole and metaphor are figurative language phenomena in which the literal meaning is exaggerated intentionally. Metaphor makes the implicit comparison to something that is literally not true. The principal is angry has neither hyperbole nor metaphor. I will walk 1,000 miles to meet you. It has hyperbole. There is an exaggeration. Life is a journey. It is a metaphor because the image is that of a journey. The principal is going to cook us has both hyperbole and metaphor. It is both exaggeration and metaphor. Now, is this a practical need? It is. This is again from data. Hyperbole and metaphor are common and their detection is important. For example, in the following chatbot. How was your day? Chatbot says. It was raining profits today. Oh, remember to take an umbrella next time. I meant I made a ton of money. That must have been very heavy. Sigh. Okay, so the chatbot could not detect the metaphor and hyperbole. So there is need to create NLP systems which deal with these language phenomena. And by the way, this is not a fiction. If you go to Google Assistant and utter Lumos Maxima, which is from Harry Potter, then this will light up. Okay. So we thought that hyperbole and metaphor often refer to each other. So why not do them together in a multitask manner? For example, this particular device is called a spork. It is a spoon and fork together. Okay? So create a neural network system which does hyperbole and metaphor together. So this is the architecture we adopted. Hyperbole and metaphor are detected by the same outer layer and deeper inner layers also. Okay? So there is heavy parameter sharing between hyperbole and metaphor tasks. But the loss function has two components, one for metaphor and the other for hyperbole. And there are standard data sets. We do not have time to go into the details of this data set. These data sets were taken by us and we augmented these data sets with hyperbole and metaphor marking. If the data set had only hyperbole, we introduced metaphor and vice versa for another data set. So these are some numerical figures. Multitask approach to metaphor and hyperbole detection had better figures as is indicated by the last row and bold-faced numbers. This happened for all standard data sets which were available and also the data sets that we created. In hyperbole detection, we have now created a new benchmark. Okay, hopefully the future papers will have to do something about crossing these figures. And they are pretty good. But the technology moves very fast. And then qualitatively also we could see that we are doing better in terms of multitask learning compared to single task learning. So now we summarize what we talked today, and maybe in 2-3 minutes I give you a few demos. So the summary of this hyperbole metaphor detection task is that it is a novel multitasking approach for the detection of hyperboles and metaphors. And we contributed data by marking metaphor on hyperbole data and hyperbole marking on metaphor data, both ways. And we demonstrated the superiority of multitasking over single tasking. So let me give you one or two demos, but here are some concluding remarks. Natural language processing is language and computation, combination of linguistics and probability. Knowledge, logic, data, and machine learning are the fundamentals. Noisy channel, gradient descent, backpropagation, deep networks are foundational techniques today. They are surely data-driven. Deep learning succeeds with data, but data is scarce. So human-machine synergy, transfer learning, meta-learning, they have to be adopted quite extensively. Rare language phenomena like sarcasm, metaphor, hyperbole also need to be detected. This is important for conversational AI, machine translation, question answering, and so on. Empathy is important for business interest. Okay, this is actually true. Okay, companies which are building chatbots want empathy on their chatbots. So sentiment and emotion in mental health space is also very important. We have started working on NLP for depression detection, for example. Generative AI is here to stay. Next 5-6 years, you will surely see generative AI flourishing, and many innovative applications are possible. So now let me give some demo quickly. So this is our multitask hyperbole and metaphor detection, but it takes a few seconds. So while this is going on, I'll show you other demos. So this is, let's say, John is a, no, let me take the sentence which I heard from Professor Mitali Mukherjee. India is a global melting pot of humanity. This is a metaphorical sentence, so it should predict it, but it will take a few seconds. So while this is going on, let me go into our translation system. Professor Chaudhary mentioned this demo. We have been improving it all the time. So English to Hindi, let's say. I'm always a bit nervous for demos, but okay. Jodhpur used to be called Marwar in olden days. It was the capital of Rajputs.
पुराने समय में जोधपुर को मारवाड़ कहा जाता था. यह राजपूतों की राजधानी थी.
Looks okay, right? Except for the spelling mistake, maybe, Jodhpur. And I take it to, from Marathi to Hindi. Hindi to Marathi, sorry. So this is a Marathi sentence. Most probably it is correct. We'll test it by going back to English. There are some spelling mistakes. In old times, Jodhpur was called Marwar, the capital of Rajputs. The original English sentence was, Jodhpur used to be called Marwar in olden days. It was the capital of Rajputs. And what we got back through this cycle of English, Marathi, Hindi, English, in old times, Jodhpur was called Marwar, the capital of Rajputs. So this is the influence of probability. Okay, the words are chosen probabilistically, so these changes can happen. Now, meanwhile, what happened to this metaphor sentence? Okay. India is a global melting pot of humanity. So this has a hyperbole score of 0.996. It is hyperbolic. And metaphor score of 0.998. It is metaphoric. Okay. And then if we look at the explainability signals, then dark regions are the contributors to this decision. But here melting pot should have been a strong signal. But we do see that these explainability signals have lower value when we are doing single task learning. Okay, you see the regions are darker here. This is 0.1, 0.08, and so on. And if this sentence is given without metaphor, in India there are many groups of humanity living together and forming a whole, then its metaphor score will be 0. A metaphor score will be very low. Different groups of people live in India and form a unified whole. This should have a low metaphor score, but let's see. But prediction will take a few seconds. So while this is going on, maybe I can take some questions. Thank you very much. Yeah, so we see the output here. The metaphor score is 0.274, okay? It is below a threshold of being metaphoric. Hyperbole score is 0.039, okay? It is not a metaphorical sentence. And if you ask ChatGPT, what do you think? Is India a melting pot of humanity? Metaphorical? What do you think? Is India a melting pot of humanity metaphorical? The phrase India is a melting pot of humanity is a metaphorical expression often used to describe India's diverse and multicultural society. Okay, and then it goes on describing the diversity and emphasizes the idea that despite these differences, now let's see if it has explained why it is saying this is metaphorical. It has given? First paragraph? Okay. Yeah, melting pot and mixing in a pot. Yeah. So, so these are the abilities which are going to be important for NLP. Okay, now thank you. Yeah.
Why did you mention you have done single task learning? Is it the cost involved for doing multitask learning, or do you think it is better?
Yeah, so there were papers on single task learning for hyperbole, okay, and also for metaphor. But all these papers dealt with these two tasks in a single task manner. So we had some linguistic intuition that many times metaphor is created by exaggeration with hyperbole. So most of the time these phenomena appear together. So why not do them in a multitask manner? And maybe this will lead to higher accuracy, which indeed was the case.
Okay, so I mean, this is a different question, but what I was trying to ask is, I thought single task and multitask in a different context altogether. Okay. Like ChatGPT has learnt on 300 plus tasks, etc.
Okay, that way.
So, the question I was coming to is, NLP becoming so resource intensive, I mean, what is the future of academic institutions in this area?
Yeah. So, the force of let's say excitement and exuberance with large language models also witnesses a parallel force of economy of resources. Okay, this is happening in enterprise definitely. Okay, so we work with some enterprise organizations where they want economic language models to be doing their NLP tasks on their specific data. So domain-specific language models, which are economical in size, are also growing in importance. So this is one direction which will surely stay. The other place will be Bloomberg for their own enterprise NLP, financial. The other interesting possibility is cross-lingual fine-tuning from large language model of fortunate languages to resource poor languages. So you might create NLP of Manipuri from Hindi large language model. These two directions are surely real. Yeah.
Hello sir, my name is Pranjal. Back in 2011 I attended one talk at IIT Bombay only on word sense disambiguation and all. And then I took my master's project and all the inspirations from your work. That was the first work in Assamese language for words and system equation using night-based classifier. Then after that I switched to design. And my question is there any plan for any language from Northeast to be included in the...
So I think one of the presenters mentioned Bhashini. Professor Chaudhary also mentioned this. So we are part of Bhashini project. And under Bhashini, there are two projects which I am leading. One of them is called Ishan. So Ishan, if you know the etymology of the word, this is a direction between north and east. Okay, so there are 4 languages: Assamese, Boro, Manipuri, and Nepali, which are part of Ishan, and we are working on Bhashini.
Nepali is already complete, I guess.
Nepali is an easier problem because we are saying Hindi to Nepali looks like a low-hanging fruit, just like Marathi Konkani.
Yes.
Yeah.
Thank you.
Okay, thank you. Thank you very much.
Thank you so much, Professor Bhattacharya, for just helping us reflect on all the ways in which we use language so unconsciously. And as teachers and parents, I think it's very interesting to see the directions of this work. And thank you so much for making NLP so accessible, even for those of us who are not from this domain. So in order to mark our appreciation for our 2 esteemed speakers who gave us such fascinating insights into their respective fields, I'd like to invite our director, Professor Shantanu Chaudhary, to confer a small token of appreciation to our speakers. May I invite Dr. Jitendra Jadavji to please come up on stage. May I now invite Professor Pushpa Bhattacharya to please come up on stage.
Just one point. Shantanu and I were wingmates, okay, from IIT Kharagpur in the same hall, RP hall.
Now I would like to invite Professor S.C. Bose, the head of the Interdisciplinary Research Platform, to deliver the vote of thanks.
Namaskar. We have come to the end of the Foundation Day celebration, 16th Foundation Day celebration. We started yesterday. And we have at least finished the technical part of the Foundation Day. Okay? And we had fantastic 2 lectures. I have been given 2 minutes only. Okay. So I would like to first thank our chief guest, Dr. Jitendra Ji Jadhav Ji. All the way from Bangalore you came. So today, history of the aircrafts. We always listen in TV or newspaper, we read so many nomenclature of these aircrafts. Okay, you made some bit of clarity today. You also talked about, I have coined that word just now, IVM, integrated that vehicle management, integrated vehicle management, IBM. And also you talked about, you are interested, it seems to be in the material science department or material activity in our institute. I hope our faculties and the students will definitely take it up. I thank you very much for, sir, all the lectures and the clarity in such a that way you gave. Thank you very much, sir. Professor Bhattacharya, for the first time we came to know that how wrong we speak. Okay? At least being a Bengali also I could guess, I could know what sort of language we sometimes took mistake. Thank you very much for clarifying lots of doubts and bringing this NLP to a very but we can use it. We can think of this. Thank you very much, sir. You also came from Bombay. In monsoon time, it is really challenging. Starting from Bombay, that is the main challenge, but you still could come. Thank you very much for this. So we had our 15 faculties. I am sure they might have digged into very nostalgic visit to their past. Some of the presentations were as old as 2006, 10, 11. I thank all the faculties who presented in a brief, though they exceeded by few seconds, but they all made to present in that 6-minute duration. I thank all the faculties. Moonshot Award was also given, and I congratulate the winner. I thank all the participants and the winner also. Our director, Professor Shantanu, I will not talk much about him. He only has given me 2 minutes. I thank him for all the encouragement and throwing all the challenges to us and helping us to come out of that challenge. At last, I would like to thank all those who have directly and indirectly helped to organize these 3 events, and the next event will be coming up. I thank all of you. I thank all of them. Jai Hind.